Yeah, now I must be audible. Like I was not speaking anything, so how will I be audible before that? My mock interview just kept on stretching. Like the question that I gave the person, like, he messed it up, so it was taking a lot of time. So that's why आप भी मॉक दो, आपको भी पता चल जाएगा कौन सा क्वेश्चन था. एक ही क्वेश्चन पूछता हूँ मैं सबसे. ठीक है. Let's start then. Is Dhwanil here? Dhwanil, Vishwa, one of you or both of you? I see Vishwa here. I don't see Dhwanil here. So Vishwa is here. So Vishwa, hi Vishwa. Is your mic working?
Yeah, hi sir, am I audible?
Yeah, you are audible. So why don't you, so they want to know your experience and essentially how you managed to get this offer from Microsoft. So you could maybe share some aspects of the experience or the process, and then maybe they can ask you some more questions, and so you'll just have it very quickly in the like next 10 to 15 minutes, and then we can start with the class.
Okay, so basically this internship, it was not an on-campus application. You can apply for it through Codes or code.fund.do++. So this is for secondaries, people who are in their second year of the major branch. And I'll just go through the process of recruitment. So first they had a quiz on your computer fundamentals, which was basically different sorting algorithms, certain things about graphs. Then the second round, the next round was, there was a programming assignment which had around 4 questions. So I felt that the questions were based more on math and concepts rather than on, knowing proper syntax and everything. And they were, one of them was on graph, one on recursion, and one of them was a proper math arithmetic sequence. So you just had to figure out the sequence and solve it. So there were 4 questions. I think if you could have solved more than 3, then you could have qualified for the next round. So the next round was the technical discussion or the interview. And I think this was the most important one. Here, I think it was split into 3 parts. So first part was about some technical questions like linked list. I was asked a question on linked list. I was asked a question on recursion. What is recursion? And then I was asked to give an example. So this is the way they'll give you some example and they'll ask you to reciprocate and develop on this. So you have to interact with the interviewer constantly, and you have to let him or her know that what is going in your mind, and they'll help you. So they help a lot in what is going on. And the second part was about the resume. So your resume has to be very effective. Whatever you write, your projects, your courses, they'll ask you upon that. They'll ask you how do you manage everything and what are you trying to do in future with respect to this topic. And then the last round is about, it's abstract. It's like what do you want to do in life, and why is this technical discuss. I mean, what is the importance of technical stuff in your life and stuff like that. And yeah, so I think the mock really helped me. I took a mock with the marks, and so the confidence was also very important because we generally overlook this, but I think it just reflects your willingness and you can handle stuff. So this was pretty much the process. So now if you have any questions like related to this, I'll be happy to answer. Okay, there are some in the chat box. Yeah, so I haven't applied. Yeah, it's off campus. So Microsoft approaches some colleges. I think almost all colleges. And so there are 2 programs, Codes and code.fund.do++. So Codes is a mentorship program for female coders. And code.fund.do++ is a hackathon. So it happens in various stages. So it was off campus, as in this is a second year internship. So you get to do this after your second year summer. So you get to do this in your second, so basically before starting your third year. So that is off campus. Application is off campus.
Right. Cool. Any more questions? So we can take questions one by one. People who want to ask question can go one by one, unmute and ask, and then go back to muting yourself. So who's asking?
Okay, could I go first?
Yeah, Karmanya.
Yes, ma'am, I'd like to know which topics or subjects were they particularly in demand of? Like what is the trend nowadays at Microsoft?
So in the coding assignment or in the interview?
Both in the part of the
Both? Yeah.
resume and the coding part.
Okay. So coding, again, so it was very math based. So for students who have just completed the second year, they don't expect you to know much of graphs and everything. So like I'll tell you, example question was that they had given a structure of a graph, and then you have to find out what is the type of graph. So it was actually very basic. And then there are, one of them was recursion. It was like a puzzle, and then it could be solved by recursion. And so basically they highlight all the important concepts. One was an arithmetic sequence, one was graph, and one was recursion. So out of 4, I remember the 3 of them. And in my interview, I was asked a question on recursion and linked list. So recursion, I was just asked what is recursion. So they want a very abstract definition that if you can just say that, okay, it's one problem and we try to solve sub problems of it. And then they'll cross question you by giving you some examples. And then you have to tell them, okay, yeah, here, this is how you can apply recursion. And another was on linked list. It was merging of linked list, but it had certain twists. And so they'll ask you to, so this was a online interview. So you were supposed to share your screen and just pseudo code it on any editor and just show it to them. So they wanted, so basically what they wanted was to see, did you understand, okay, what type is, what is the signature of a function, what are you returning, why are you returning, what are the parameters you're taking, basically what your function is doing. And that was, and your algorithm. For my interview, so whatever is the thing that reflects the most on your resume. For example, you are doing extra courses in ML or DL or AI or security or anything. So they'll just ask you that, okay, how do you manage this, and tell us about any course. Just tell us. So in this part, they won't cross question you. They'll just ask you for your experience and how do you want to carry ahead in this domain. That's basically about it.
Thank you.
Yeah.
Yeah, so just a point that I would like to add to this is these are different things. So university, this was the internship drive as part of Codes or Code Fund 2++. So the processes will generally, like while the template or the main aspects of the process might still be the same for university placements as well, like the level and the type of questions that they ask might differ. So that's another thing that you should keep in mind, because it was primarily they knew that these students are just second year passed out. You cannot expect a lot from them. You cannot expect fundamentals of operating system because they haven't taken a course on that. So the interview process reflects that aspect as well. So they design it in that manner. So just keep that in mind, and so take whatever she is saying with a pinch of salt also, unless you are sitting for internships. Okay, next question. Who's going next? Swami, you have a question. Pradyum has a question. How similar was your interview to the top 100 Microsoft lead code questions?
Yeah, so again, if you are just as Sir said, this was for second, like people have just cleared, like passed their second year, so it wasn't very tough. But I think the question that we do on lead code, that is what we can expect for third year internships. Like that is what I think it is. For us, it was not very tough. It was somewhere you can say medium level questions.
Right. same procedure, Swami, as a question, is the procedure same for off-campus placement as well?
So basically, like for my campus, it does not have a proper, the placement year does not have a proper scheduling for second year internships. So I had to do this on my own. But like reaching out to Codas, yeah, that was a part of PU. As a, like for third years, I don't know how off-campus placements work. So I don't think I can answer that question completely.
Yeah, so there are two things. See, if there is a significant trend these days wherein companies are looking to diversify their tech talent and their engineers, and they are looking to hire a lot of female employees in their organizations. So they have there are a lot of programs which are specifically catered for this. Like Microsoft has this Codes. Uber has some C or C code, like some one of like some of you can C++,
Yeah,
yeah.
C++.
Then similarly you have other programs for Google as well, and so all these multinationals, they have programs specifically for girls, wherein they are basically interviewing people, girls, and looking to hire tech talent who are female employees uh, into their teams. So if you are a girl, you can expect to, or you can look up or read more on these, and these are a good source for off-campus internships and placements. So generally, that works out well for girls. That I have also seen in the past from my experience. And for for the generic audience, campus placements as of now is there is the university placement route, which is basically the company comes to your college, and they have a university hiring team that's dedicated for that. And so the way it works is they first they first collect requirements based on the internal team's requirements, as well as based on the total the percentage increase they want in their employee count. They come up with a number, like they say they come up with a number like 70 students we need to hire from India, from engineering graduates across the country, and these are the colleges that will be going into. So that's sort of a high level number that they come up with, and after that they start the university recruitment process, wherein they send employees to campuses and book slots in placements, and then they basically interview and select from them. So that's pretty much how university recruitment works. And so for freshers, generally, if you refer, put in a referral, or you go ahead and apply off campus, it's highly unlikely around this point in time that you will get an interviewing opportunity, particularly if the company is coming to your campus. More often than not, they will tell that we are already coming to your campus, so you should apply from there. That's solely because the recruitment is for a fresher is through that process. It's not similar to a lateral hiring. So that's one of the challenges of campus recruitment. So that's why around this time, if you are June, July, August, September, when companies come to campuses, if you are applying off campus in the same company, particularly if the company has already visited your campus, it's highly unlikely that they will choose you. Because they will have to go through the university recruitment route, and the university recruitment route does not allow it. They cannot go through the normal lateral hiring route, because in the normal lateral hiring route, the process is such that they expect you to join in a month, or almost immediately after you are done with your interviews and after the formalities are completed, which you cannot. You have to wait for an year. So because you are passing out next year. So that's why the processes are different. So generally off-campus works best for these companies around the month of April, March, April, when you are just about to pass out. And then you can basically treat that hiring as a lateral hiring. And you can apply specifically for positions that are vacant in companies. So then it's a lateral hiring that you will go through. So that's the difference. And that is a hack that you can do. Yeah, I mean, we can talk more on that. We can have a session on that. That's okay. But that's just some high level direction that I wanted to tell you. More questions? Sir, ये ठीक है. Any more questions from Vishwa? For Vishwa? Anyone has any question? All right, guys. Then we'll assume that there are no more questions from Vishwa. As far as this is concerned, like we can have a session on that towards the end after the course completes, wherein you can ask your questions, and maybe like some of us I can like put in, or I can group in more people and who have some experience with off-campus uh, processes and who have managed to get some offers off campus, and they can talk about the process, and you could get a better idea about that. Okay, sounds good. Are we good to start with the class then? Others? All right, Vishwa, thank you. All the best for your internship and wish you loads of success. And thank you for sharing your experience as well. Okay, so back to business then, back to what we've been doing. Let's So we've been looking at 2D dynamic programming, right? So I will just recapitulate whatever we have done so far in the interest of people who have missed out classes in the past, in the last few days, as well as for people who were there, but just to make sure everyone is on the same page. So far we have looked at four types of DP problems. We have looked at 1D DPs. In 1D DPs, we have looked at order n DP with order n solutions and DP with order n square solutions. We have looked at the different types of decisions that entail such solutions. So some notable decisions that we looked at were include, exclude. So you make a choice on whether you include the current element or the first or the last element in the solution or not. And based on that, you make a decision and define your subproblem. So that's that's one decision that we have looked at. Then we also looked at decisions wherein we were looking at the first element of the solution. So questions like word break or palindrome partitioning, wherein we were looking at the first element, and we said that the first element could be any of the numbers from the entire array. So we will take all those possibilities into account, and assuming it is the ith element, we will formulate our recurrence and define our subproblem, and then we will do it for all the i's and take the maximum, minimum, or sum depending on the type of question. So that was another decision that we have typically looked at. We also looked at questions involving subarrays and subsequences, wherein you had to find the longest subarray or subsequence satisfying a particular property. And the chief decision here was we were looking at the predecessor of at that particular index. We said that if I were to consider the longest subarray ending at I, what could be its predecessor? That's the question that we were trying to answer in formulating the decision. So in subarray, we said that the predecessor could either be I or I minus 1. For subsequences, we said that the predecessor could be any j which is less equals I. So assuming these are the predecessors, we will basically recurse over all these possibilities. So that is another type of decision that we had looked at in 1D DP. Correct? So some notable questions, we did questions on subarray subsequences, we did palindrome partitioning, we did word break, and we did questions on like house robber, wherein we were talking about the include exclude decision. Right? So these are like some so this is all about 1D DP. Does anyone have any questions on 1D DP? Are you able to understand or recollect all these? Is there any other decision that we did, which I forgot to include? 1D DP is clear 80 to 90% to most of you who are there in the class. Can you get a feeling and an intuition also? right? So then we looked at 2D DPs and the type of decisions that come with 2D DP. Again, 2D DP, you can have the minimum you will have is n square, because you will have n square possibilities, right, for the sub problems, and you can go up to n cube and even higher dimensions, even more running time. So we looked at 2-dimensional DP, and we looked at the types of decisions that we can have for the 2-dimensional DP. Similar decisions we looked at the famous knapsack problem. We looked at unbounded and bounded knapsack, both the problems, and we looked at the types of decisions which can help us solve the problem. So the decisions were again very similar to the decisions of 1D DP. We looked at include, exclude, and we looked at the first element of the solution, right? With both these decisions, we were able to solve the unbounded knapsack problem, and we actually implemented the unbounded knapsack on HackerRank with both the decisions. For bounded knapsack also, we try to think of both the decisions and see what kind of running times we get for both of them. With the include exclude, we were able to get an n square running time, but with the first element of the solution, with this we were getting subsequences as sub problems, so that was going for leading to an exponential time. So that was basically the types of decisions that we have looked at. And we discussed in detail about several dynamic programming principles apart from this, which are generic for both 1D and DP, 2D DP. So we talked about the steps that it is recommended to follow when you approach a DP problem. First of all, the identification for a DP problem. The identification for a DP problem is you either have an optimization problem or you have a combinatorial problem. Typically, these types of questions can be solved best with dynamic programming. We looked at the steps that you should follow when you go about approaching a question using dynamic programming. So we looked at, we said that the first thing you should do is you should come up with a decision. And we have already looked at some typical decisions. We will look at more decisions. So once you have the decision, you can define the recurrence. Once you have the recurrence, you can try to understand the sub problems. So you can get an idea about what is the sub problem. And then I was telling you about a step, which is simulate the sub problem, simulate the filling of the sub problem. So once you have the sub problems, you can check for overlapping sub problems. So you can just draw one level of recursion tree and check and see for yourself that the same sub problems are being computed again and again on the recurrence. And once you know that, you know that dynamic programming is one way which you can use. So once you have arrived at the decision that you want to use dynamic programming, you can simulate the filling of the sub problems. So that will give you an idea of the order in which you are filling the sub problems. And this is very important. Like for instance, 1D arrays, 1D DP, we had prefix arrays and suffix arrays mostly, right? So we said that we will fill from the smallest prefix array, which is 0, 0 or n-1, n-1 to the biggest prefix array or the biggest suffix array. So that was the order in which we will fill the subproblem space, right? For 2D DP, we said that now the subproblem space is a 2-dimension. So we could represent it as a matrix. So we looked at the matrix and we said that for when we are at a given ij in that matrix, what all subproblems we are using to solve the current subproblem. So we said that, let's say you are standing here. So you want to solve this particular subproblem. Then what all subproblems are you using to solve this particular problem? And based on that, you can define an order in which you will fill out this matrix. So that order could be row wise. You fill out starting from the first row and the first column and gradually increasing, going right, increasing the column, and then coming back and starting over from the second row and so on. So you could go ahead and do it in that order. If that is one possibility. The other way is you could, we saw a couple of questions which were length DP. So by what I mean by length DP is, we were looking at problems wherein we need to fill this matrix array diagonally. So we were using, when we were at a given index, we were directly using the solution from an element which was in the diagonal path or from a cross diagonal path. So that basically told us that we want to fill this matrix diagonally. So those were the two types of 2D DPs that we had looked at. So all those come in this section, wherein you determine the order in which you fill the subproblem space. And that is very important, especially when you are constructing a bottom-up approach for your solutions. Bottom-up approach, you need to write your iteration or your in the same order. So it's very important to determine the order. And we also looked at, once you are done with the coding, you can see if you can optimize the state space, optimize the space. So how do you optimize the space? If you are just using the previous element or the previous row, we looked at questions wherein we were just using the previous row or the previous element. So if we are doing that, then we don't need to store the result for all the rows. We could just store the previous row and the current row and keep shifting, right? So we looked at the modulo, how modulo helps us achieve that. So we looked at that as well. So that is in a nutshell what we have done so far. So any questions on this part? This part is probably, I think these two parts, many of you are clear with this, because you have, like we discussed this extensively in recursion as well. But but determining the order is something that we introduced in the last class, and as well as space optimization. So any questions in this, or you understand both of this? Any questions? You get a feeling and an intuition also? All clear? Others? People who missed classes, for whom it became hectic, or people. So you get a feeling, right? So that's why it is generally recommended, go for a bottom-up approach instead of a top-down approach. It helps you get a lot of intuition for the sub-problem space. But top-down is generally, we will look at top-down problems today, but generally top-down is that kind wherein you can get away by not even getting a proper intuition for the solution or for the order. Correct? So in 2D DP, so we will continue from there. So in 2D DP, we have essentially looked at row-wise filling. Like, so we have looked at questions wherein we were filling the state space or the space of all sub-problems row-wise, right? So we looked at the knapsack problem. That's the famous problem that we looked at, both the bounded as well as the unbounded knapsack. And we looked at a couple of variants of that. Like just one question we looked, which was on Tushar's birthday, which was just a minor change that you needed to make to knapsack. Then in row-wise filling, we looked at a zero-sum game as well. So we looked at a couple of questions which had, or in fact, just one question which had which was related to a zero-sum game. So there was a situation wherein two players were playing alternately, and they had to optimize something based on the conditions. And we saw how we can construct a DP approach by keeping an index, by keeping the player as well in the space, in the subproblem space. So that was one approach we saw, wherein we said that the player will also be considered in the subproblem. And then we looked at one smart way or a neat trick for eliminating that by taking the difference of the scores. So the difference of scores is not really dependent on the order or on the player who is going first or on the order in which it is being played, right? So we looked at a neat trick for that as well. So that was another question that we did in the zero sum in two-dimensional DP, wherein we were filling row wise. In fact, this was actually one-dimensional DP, right? Like the question that we looked at, because that was there, you just had three choices, 1, 2, or 3. So this is not really in the 2D case. We looked at, after this, we started with, so we looked at arithmetic expressions. We looked at that question wherein you had to plus minus append plus or minus to every number and come up with a sum. Or we also looked at the subset sum problem wherein you had to find a subset with a given sum or find all possible subsets with a given sum. So those were all two-dimensional DP problems. So in three types of decisions we have seen in two-dimensional DP problems. We have seen the include-exclude decision. We have seen the first solution, the first element of the solution decision. And we have looked at questions wherein the decision is explicit, right? Like this question, arithmetic expressions, the decision was explicit. It was given that for a number, you just either have to give it a plus or a minus. Depending on what you give it, you have different possibilities for the sum, right? So we looked at these types of problems. Then we started with length DPs, and we looked at so in row-wise filling, all these questions, we basically looked at, we were given an array and an integer. Typically, our state space encompassed these two things. You had an integer and you had a sequence that was given to you. And you had, so we saw how these decisions help us in achieving what we want to achieve, right? The other important aspect we looked at two-dimensional DPs wherein we have two sequences. So we don't have an integer, but we have two sequences in our problem space. And we looked at the decision. So what was the decision for this? We looked at edit distance. We looked at the LCS problem, right? So these were all longest common subsequence, longest common substring. We looked at both these questions. So these were row-wise filling questions wherein you had two sequences, right? So you had two arrays and you had to find the longest common subsequence between them. You had two sequences and you had to find the longest common substring. You were given two words, you have to convert word 1 to word 2. So you have to find how many minimum operations are needed to convert that one sequence to another sequence. So in all these questions, you had two sequences. In all these questions, you had one sequence and an integer. And these were typically the decisions that comes in handy. In this kind of scenario, what was the decision that we were looking at? Anyone?
Sir, in which problem you are talking?
I'm talking about questions wherein we had sequences. We had two sequences in the question. So see, in 2D DP,
Looking at the last card.
Looking at the
Last element.
Looking at the last element of both the sequence, right? And coming up with a decision on that. So it's a joint decision that you are making, right? So you are making a decision by looking at the last element. So you look at the last element. So it is very similar. If you remember, in 1D DP also, we were looking at the last element, right? For decisions, for problems involving subarrays and subsequences, if you remember, we were looking at the last element and we were making a decision on the last element, that who could be its predecessor. That was one decision. That what are the decisions that we have made by looking at the last element in the 1D DP? We looked at the last element, and that one decision that we made was you could include or exclude this number in the solution, right? That was one. The other set was we said that who could be its predecessor. Let's try and find out its predecessor, right? So these were the decisions for one-dimensional, wherein you had just one sequence and we were looking at the last element of the sequence. Correct? So now if you have two sequences, we were looking at the last element of both the sequences together. That was basically what the activity that we were taking. So in longest common subsequence, what we said was they could be the same or they could be different. If they are same, then we are left with a particular type of subproblem. If they are different, then we are left with a certain type of subproblem. So it is not very different from what the 1D counterpart, if you really think about it, like take some time out and think about it. It's almost the similar. It's just that they have been extended to take into account two sequences. So these were the questions that we did in length, in row-wise filling, wherein you had two sequences. any questions on this? This was a little more difficult to come up with. Understanding was okay, but coming up with it on your own was a little more difficult. But do you understand this, all these types of questions? Right? So we also, so then we moved on to length DP, and we said that we looked at questions wherein we had to fill out the elements diagonally and not row wise. So we looked at a couple of questions. We looked at the longest palindromic substring and the longest palindromic subsequence. Right? So we looked at these questions, and we will code this today. I just gave you a high level idea about what it was. So here also we were, so in all these, we had in these questions, we just have one sequence in the question, which is the array, the original array that is given. Nothing else is there. But we are basically iterating for all. So the sub problem in this case, in these cases, was that we had all possible sub arrays as sub problems. So you fix the starting index and the ending index for a particular sub array, and you get a sub array, and you try to find that from smaller sub arrays. That was the idea behind the length DP questions. So we will discuss this today first. We will code it out, and then we will move on. So let's look at the longest palindromic substring question. Let's begin with that. So the question was that you are given an array and you have to find the longest substring, which is a palindrome. You have to find one substring, one I and j, which is a palindrome. So that was the question. And now one of the things, the pattern is you see a substring that you have to find, a longest substring, some kind of a substring, right? So you can try it with dynamic programming. If you remember in 1D sub, we have already handled 1D subarrays and substrings, right? So in 1D subarrays and substrings, we were basically talking about the subarray ending at a particular index I, right? Here we say that let's talk about all subarrays, and let's say that we want to find it out. Or so here the decision was, let's take this entire substring. So we want to find out for all possible substrings within this array, whether they are palindromes or not, and then take the maximum out of them. So we will iterate over all possible I and j. We will fix an I and j, a pair, and we will check if it's a substring or not. Or we will check the longest palindromic substring that begins with I and ends with j. Right? That was the decision that we made, which was very similar to, if you remember, the 1D subarray counterpart. We were saying that we want to find a subarray ending at a given index I, and then we will take in the result, we will take the maximum for all I. So the result will eventually end in some index I. So we will find the longest subarray ending at I for all the subarrays, and we will take the maximum out of it. That was what we were doing in 1D subarrays. Here also we will say that every substring that you know, or the resultant substring, which is the longest palindromic substring, will begin at a given index and end at a given index, right? So we will find out for all ij and then take the maximum. So for all ij, for every ij, we will find out the longest palindromic substring that begins at I and ends at j, right? So we said that we want to find that out, and we will take the running maximum, right? So what was the condition here? So if we have to do this, the condition was, we will check, the decision was, again, we will check this element with this, right? So if this and this are same, then basically we know that we will find out the longest palindromic substring for this. So we will find out the longest palindromic substring for a I plus 1 to j minus 1. And if that longest palindromic substring for I plus 1 to j minus 1 is equal to the length, So if it is equal to the length, what is the length? The length is j minus 1 minus I minus 1 plus 1, right? So it is j minus I minus 1. So if that length is equal to j minus I minus 1, then my total longest palindromic substring ending at I, ending at j and beginning with at I is 2 plus this. And if the length is not this, then we know that you cannot have a longest palindromic substring ending beginning at I and ending at j. So we will have a length of 0. Right? So this was the decision that we made. Any questions on this decision? So let's quickly code it then.
Sir,
And then,
sir, why there is 2 plus? Because is it like we had computed that somewhere else?
whatever is the length for this, what is the length for this? It is 2 plus this, right? What is the length for this
Okay.
entire thing? It is 1 plus this plus 1.
Okay.
Correct? So this is what the decision was, and this is how we would go about doing it. For longest palindromic subsequence, what was the decision? We said that we want to find out the longest palindromic subsequence. For subsequence, we said that we want to find out the longest palindromic subsequence for this array, for every ij, whatever is the longest palindromic subsequence. So there the decision was simpler, that if this element and this element are same, so if they are same, then you have 2 plus bp of I plus 1 j minus 1. So the longest palindromic subsequence is whatever this subsequence plus 2. Correct? And if it is not the same, then we have two cases. We either take the longest palindromic subsequence I plus 1 to j, or we take the longest palindromic subsequence I to j plus j minus 1. I to j minus 1, yes. Right? Because you cannot take I and j together now in the subsequence. So you try this, or you try this. So it will be the maximum of these two. So this was the longest palindromic subsequence. Is everyone following? Do you understand longest palindromic subsequence and substring, the sub problem? Yeah, as well as how we came up with it. Like we drew some analogy between the 1D counterpart and this as well. So that is also another thing to keep in mind. So now if that is clear to you, one of the next key steps that we do, so we can just check for that it has overlapping sub problems. And how do we do that? It's actually very simple. Let's say for a given ij you want to compute. So for a given ij, your sub problem is I plus 1 to j minus 1. Correct? This is your sub problem that you will solve at some point. Now let's do it for, let's try I plus 1 to j plus 1. For this also, if when you find the longest palindromic subsequence or substring, after 2 steps you will have, sorry, this is I minus 1. After two steps, so after 2 decisions, you will again be left with this problem only, I plus 1 to j minus 1. Correct? So it's the same sub problem that you are trying to solve more than once. Once when you are doing for ij, then again when you are trying to do for I minus 1 to j plus 1. And similarly, you can keep increasing the length, right? As you increase the length, the same sub problem you are trying to solve again and again, right? So that's how we come to the conclusion that there is an overlapping sub problem. There are overlapping sub problems. So we should use dynamic programming. So and once you know that we should use dynamic programming, you should figure out the order in which you fill the sub problem space. So for that, what we do is let's try and fill out the subproblem space for this. So so for that, what you have is, what is the subproblem space? The subproblem space is all subarrays, right? So we can have the start index of the of the subarray in as rows. It could go all the way till n-1, and we can have the end index as columns. So go all the way till n-1. Right? So this is the subproblem space. It's very important that you understand that this is the subproblem space. Now, if this is the subproblem space, let's see. If you are here, so one thing is you are only interested in values which are greater, which are towards this half of the line, right? Because these don't make sense, because this is the start index and that is the end index. So the start index cannot be greater than the end index. So anything that we do will be on the right side of this line y equals x. So we will have everything to the right side of that. So these values are, we should be not really concerned with that. We should be concerned with values on this line as well as to the right of this line. So greater equals this line. Now let's see if we want to try for this. Let's say we are trying for this. Let's use a color, green. I don't know, I was never so colorful in my life. Let's try this. So for this cell, what is the actual subarray we are looking at? We are looking at 1 to 2, right? So we are looking at this subproblem. Or let's try a bigger subproblem just to make things better for you. Let's try this subproblem. So let's say this is 3. So you are looking at 1, 2, 3. You are looking at this subproblem. So the start index is 1, as you can see, and the end index is 3. How are you going to fill this? If you remember the recurrence, you were checking for this and this, if they were equal or not equal, depending on, so let's talk about the LPS, longest palindromic subsequence problem. So in the longest palindromic subsequence, what were the subproblems? If these were equal, you were left with this. So this is 2, 2, right? So let's find 2, 2 here. So where is 2, 2? 2, 2 is this. So you were using this value. Correct? And what if they were not equal? What are the values that what are the values that you will be using? If they were not equal, then you were using 2, 3 and 1, 2 and taking the maximum of both of them. Right? So where is 2, 3? 2, 3. So you were using this. And you are using 1, 2. Where is 1, 2? This is 1, 2. Right? So basically you are using these 3 values at any point to compute the value at this particular cell. And if you see, we are using, when we are here, if you observe carefully, when we have a subarray of length 3, we are using solutions for subarrays of length 2 and subarrays of length 1. So that naturally tells us that let's go about solving the subproblem starting from the smallest subarray to the largest subarray. So let's solve for this diagonal first. This diagonal will give us all subarrays with length 1. Then let's solve for this diagonal. So this diagonal will give us all subproblems for length 2. Then let's solve this diagonal. This will give us all solutions for length 3. Then solve this, length 4. Then solve this, length 5. So let's go about solving subproblems in this manner, so that when you are at a given length, you already have computed solutions for smaller lengths. And because of that, you will be able to readily populate the DPI. Is this part clear to everyone? how we are going about filling or determining the order in which we fill the subproblem space? Lengthwise. Are you able to see clearly that this helps, or this is the right way to go about it? Yeah, so then we will see one sample solution as to how you should go about implementing this, because you have a length constraint here, right? So you want to start from the smallest length and go up to the biggest length. So we will see one solution for a typical implementation of this kind of an approach. When you go row wise, it's easy, right? Because you can just iterate, you have a normal iteration as you would iterate on a matrix row wise. So that code is relatively easier. Here the code will become a little more complicated than what would you do if you were filling it row wise. So let's look at one typical solution for that. Does LeetCode have longest palindromic subsequence problem? I think it has. It has. This is 516. So let's see 516. So let's try this question. So we know, let's write out some basics of this. Let's just, yeah, I think this is good. So we know that it's a DP array on DP problem on length, right? So we will have a vector which will be there for all sub. So what will be the size? It will be n by n, right? So let's have an n by n DP vector. Let's initialize it with 0. What is the base case? The base case is the smallest length. So the smallest length is subarrays of length 0 and 1. Let's just say we want to populate these two. So subarrays of length 0, you by default you have a 0 here. So you don't need to think about that. Let's just be concerned with subarrays of length 1. So all those subarrays are 0, 0, 1, 1, 2, 2, 3, 3, so on, right? So let's go from 0 to n and dpi. This is the principal diagonal in the subproblem space. This will be 1, right? Because every subarray of length 1, 1 is a palindrome, correct? So now we will have the main DP formulation. So in the main DP formulation, I will iterate on the length, right? So I will go from length 2 to length n. So my outer loop is on the length. Just see the template for this. So my outer loop is on the length, and my inner loop will be on the starting index. So once I have a length and a starting index, I have a subarray, right? So I will iterate over all the starting indices for this length. So the starting index will start from 0. What will be the last index? So j plus I minus 1 should be less than n, right? This will be the last index. So when you want length I starting at j, so what will be the last index of length I starting at j? It will be j plus I, right? If you have a 2 length, j plus I minus 1, right? So that last index will be less than n. क्या प्रद्युम? Is this correct? You can do n+1 also, like, but I don't see a need for that. Is this correct? Whatever I have written so far, for outer loop is on the length. So I am going from length 2 to n, and the inner loop is on. Once I have a length fix, I am fixing the starting index. So my starting index for all subarrays of length 2 will start from 0. And what will be the last such index? It will be, so it will be this, that the last index is an index such that that index plus the length, yeah, it's the same thing, n-i+1 only I have written. Yeah, Karmani, if you take it on the other side, it's the same. So that index, the starting
yes,
index,
sir, I understood.
yeah, the starting index plus the length should be less than n, should be n-1, should be less equals n-1. Correct? So that is where you will end. So what is the last index for a subarray of length I starting at j? It is j plus i-1, right? So that should be less equals n-1, or that should be less than n. That's how the condition comes in the inner loop. So ask me questions if you don't understand this. I can show it on the whiteboard. But now you know that the subarray that we are talking about is, subarray is from j to j plus i-1, right? So we want to fill dp of j plus i-1. Correct? So we have two cases. If the j and j plus i-1 are equal, so we will check if j and j plus i-1, if these two characters are equal, then my dp becomes, so then it is dp of j to j plus i-1 is 2 plus dp of j plus 1 to j plus i-1 plus 1, right? Minus 1 minus 2. Correct? So that will how it will be. So the only thing is, yeah, I mean j plus I will at least be 2, right? So this should be fine.
सर आप एक बार वो दो
क्या चीज?
dp of I, j में actually value कौन सी है? मतलब what does it contain?
dp of I, j नहीं है वो, dp of j, j plus i-1 है. उस बेसिकली वो ये डायगोनल का बात कर रहा है. तो we are going diagonal wise. So this is the first diagonal. This was the base case. We just initialized for this diagonal कि 0 0 का वैल्यू 1 होगा, 1 1 का वैल्यू 1 होगा, 2 2 का वैल्यू 1 होगा. Then we are going from length 1. So for this length 1, what we are doing is we are fixing a length. So the length is the outer loop 2, and the starting index is what we are fixing. We are fixing the length and the starting index. So starting index could be 0, which will be for this cell. The starting index could be 1, which will be for this cell. The starting index could be 2, which will be this cell, 3, 4, and so on. Right? So for filling this, we are just using the same thing, that if, so let's take 1 2. If you want to fill this, let's take 0 1. If you want to fill this, what are you saying? You are saying that if they are equal, then you are talking about, if this and this are equal, then you have 2 plus whatever remains. You don't have anything. So start index becomes, the end index becomes 0, and the start index becomes 1. So for that, basically you are saying you are taking values from this 1 0, right? Here you have already initialized it to 0. So this will be filled with 2 if these two are equal, right? And if they are not equal, then you are talking about taking the maximum of this or this. So you are talking about j, because the index is j to j plus I minus 1. So you will talk about j plus 1 to j plus I minus 1, or which is this part, or you will talk about this. So this will be j to j plus I minus 2, which will be this. So basically you are talking about j. So for 0, 1, again, if you are doing it, you are basically talking about only 0, 0, which is this, or you are talking about only 1, 1, which is this.
Sir, why
Yes, it's
outer
fine.
for loop is I equal to 2?
1 for length 1, we have already initialized it, right?
Oh, okay.
See the code, you will. So that's what we are doing here. And if they are not equal, then we are saying that dp of j to j plus I minus 1 is maximum of dp of j plus 1 to j plus I minus 1 and dp of j to j plus I minus 2. That's it. And you keep, so that's basically it. And then finally you can, so dpij is the longest palindromic subsequence. So you could return dp of 0. So the length starting index is 0 and the ending index is n minus 1. Let's try some more cases before we eventually submit it. So everyone understands this? Ask me questions if you don't
So
understand.
could you
it.
explain the maximum part once again?
Yeah. Okay, I'll do that. So this is a question which has been asked by Adobe a lot number of times. For some reason, they just keep asking every time. Just one tidbit. So the maximum logic stems from the fact that if, so what we are saying is you have two cases when you are considering for a given ij. Either these two characters are equal or they are not equal, right? If they are equal, then it will obviously be whatever you get from this, whatever is the longest palindromic subsequence, you will have some characters from this, which will form a palindromic subsequence, right? And you can extend that by 2 by including these two. So that is the case when you have equality, when these two elements are equal. If these two elements are not equal, then what we are saying is that you choose the longest palindromic subsequence for this or the longest palindromic subsequence for this, just these two. And the reason behind that is, one thing is for sure, right? Whenever you take the longest palindromic subsequence for this will always be greater than the longest palindromic subsequence for this, right? For a prefix of the same sequence, the longest palindromic subsequence for that sequence will be less equals the longest palindromic subsequence of the actual sequence, right, Karmanya?
Yeah.
So we are just using that fact here.
Okay.
So we are saying that take the maximum of just, so now basically these two elements cannot be together because they are not equal. So you can never stretch the subsequence by including both of them at the end, right? So we are just saying that, okay, then take one of them. What
Maximum of the subsequence in between them.
Yeah, maximum of the subsequence in between them, including the first element and excluding the last element, and the maximum of the subsequence excluding the first element and including the last element.
Yeah.
So ask me questions. Is there any question? If it is clear, you can acknowledge and we can move on. So this is typically how you will write length dp. Reverse the string, find the longest common subsequence. Yeah, you could do that. That is correct. So this is a typical question wherein you will use length dp. Okay, if this is clear to you, let's do one more question on length dp, which is relatively more like a little more difficult. Let's try stone game. 877. This is 877 Purva, if you are here. हाँ वो नहीं कर रहे हम लोग डीपी वाला सोल्यूशन करेंगे इसका आयुष So what is the decision? This is a question which has an explicit decision, right?
Sir,
Yeah.
we could choose either to include, like it is given in the question, we could either choose to include when Alex has a chance, he could either choose the first element or the last element.
Okay.
If he chooses the first element, then
Mm-hmm.
the remaining subarray
Mm-hmm.
will be the new problem and our player will be Bob.
Right.
Now, again, he can choose first or the last element.
Right.
So if he chooses first element again,
Mm-hmm.
then we remove two consecutive elements from the original problem,
Right.
and we are left with the new subarray and Alex chance. So we could recur for that, or it could happen that Bob chooses the last element.
Mm.
So then we have for I comma j we would have subarray I
I
plus
plus
1,
1, j minus 1.
or like if in the first case it could happen that Alex chooses the last and then Bob chooses first, then also I plus 1 j minus 1,
Mm.
and if Alex chooses last, Bob chooses last, then I comma j minus 2.
Correct. That is right. Can you do it with the difference trick, Gita? Like then you don't have to go 2 steps. Because 2 steps, the problem is with implementation, it might become a little tricky with cases, base cases, right? You're doing -2 or +2 1 minus 1.
So, sir, like we could do it this way. Uh, if we are choosing the first, if we are choosing the first element,
Mhm.
then our sub problem would be I plus 1 comma j,
Hmm.
and chance would be of Bob.
Right.
So we could calculate the answer for Bob
Hmm.
and subtract it from the total suffix array or the prefix array. That would be the answer for Alex.
Yes, that's one another way you could do it. And what is the, can you use the difference trick that we talked about in the last class, like wherein your DP stores the difference between the scores and not
Sir,
really the score of Alex or Bob?
I had a question. Like in that question, we were storing the difference between the two players.
Mm-hmm.
Uh, it was storing the maximum difference between P1 or P2.
Yeah, it was basically storing the difference, assuming both players play optimally and P1 goes first. It was storing the difference P1 minus P2, assuming P1 starts first and both players play optimally given as per the constraints of the problem.
So, sir, why were we taking maximum?
Why were we taking maximum? Because the current player who is playing is playing optimally. So he, in his optimal solution, he has to optimize for the maximum score that he can get. So he will try the path which will give him the maximum score.
Yes, sir. Uh, so P1 minus P2, uh, you are saying like P1 minus P2 would be maximum.
P1 is starting, right? So if
Yeah,
P1 is
P1 is
starting
starting.
and we are looking for and P1 will play according in a manner such that he or she gets the maximum score. So if
Then
he or she gets the maximum score, what is P1 minus P2 in that case? It will be the maximum out of
maximum.
all possible differences.
Yeah.
So that was what it was based on.
So, sir, we can do this that way also. Like
Yeah.
we could store the difference and the first element minus DP of the remaining.
करेक्ट, ये तो हो जाना चाहिए, बहुत इजी है अब. If you understand the game वाला question, did you understand Geetan's solution? Geetan's proposed 3 solutions, all of them are correct actually. So he said, let's talk about all the 3 solutions. So what is that? This is 2 and this is 3. So the the decision here is explicit, right? That you are given a sequence of numbers and now whoever is starting, can I only pick an element from either here or here, right? So he can either pick it from here or pick it from here. So so let's say this is the entire sequence. So if Alex is starting first, if Alex picks this, then so if this is the entire sequence, if Alex picks this, then he is left with 1 to n minus 1. He gets A0. And whatever the maximum he can get from 1 to n minus 1, but with Bob as starting. Right? Whatever he can get from there plus A0. No, we are not going to pick the maximum out of first and last. That is not right. Do you want to see a counter? It's very easy actually. You can give so if you give him, let's say you give a 1 here, you give a 5 here, and just before this you give a very large number. What happens now? And now just fill any small numbers. So if Alex goes first, picks 5, Bob will pick 6,999, a very large number. But if Alex, let's not have this. We want Alex, in the optimal solution, we want Alex to pick this. Okay. So let's say that you protect this with something. Let's say you protect another here, 4. But if Alex picks 1, then Bob will have to pick from 4 or 5, right? So whatever he picks, Alex can pick 6999. So this will be the maximum for Alex, and this will be the maximum for Bob that he can get, right? But if you go by your strategy wherein you are picking the maximum, you will pick 5 and you will give 6999 to Bob, right? Right, Harsa? Do you understand this counter example? So just greedily picking the maximum out of the two choices will not work. Because you might have a number which is very large, which is hidden between before the largest, before the greedy choice that you make right now, right? So you expose that to Bob, to the other player, while on the other hand there could be a path of reaching this if you choose the smaller one, right? So that's basically the intuition on the basis of which I have constructed this counter example. Everyone understands the counter example? Why just greedily picking the maximum out of the two does not work? So
काउंटर का एक बार बता दो.
काउंटर का एक बार बताएं, अंडू करना पड़ेगा, ठीक है? ये एग्जांपल है, काउंटर एग्जांपल तो यही है जो मैंने बनाया, 1469995. If you have this sequence, then if Alex is picking the maximum out of 1 and 5, then Bob will in the next step pick 6999, right? So in this example, this is the example 1, 4, 6999 and 5. So if you are going by the choice that Alex picks the maximum out of these two, then Alex will pick 5, then Bob will pick 6999, and then Alex can pick 4 and Bob can pick 1. So the scores for Bob and Alex will be, for Alex it will be 9, for Bob it will be 7000. Whereas if Alex had picked 1 in the first step, then Bob would have picked 1 from 4 and 5. Let's say he picks 5, then Alex could have picked 6999 and Bob could have picked up 4. So Bob's score would have been 9 and Alex's score would have been 7000. So picking the greedy one is not helping Alex reach the maximum. The maximum that Alex can get from here is 7000.
Got it.
So the first solution for this is that it's an explicit decision. So you don't have to break your head too much about the decision. You know that Alex has only two choices. He can pick from the first or pick from the beginning or pick from the end. So let's say he picks from the front. So if he picks from the front, this is what he's left with. He's left with 1 to n minus 1 and Bob starting the round. So whatever he can get from there plus A0 will be the answer. And if he picks A minus 1, then the sub problem becomes 0 to n minus 2 and Bob starting, right? Whatever he can get from this plus a n minus 2, right? So you clearly there is a need for, so what are these sub problems? If you see, these sub problems are sub arrays, right? These are all sub arrays of the actual problem.
Sir, can you repeat the second one? What's going on there?
No, I just said if Alex picks this one, right? So if Alex picks the 0th element, then he is left with 1 to n minus 1 and Bob going next. Whatever he gets from this plus A0 will be his maximum score.
Is it Bob's maximum?
Whatever he gets from this condition, this situation that you are left with 1 to n minus 1 and Bob is starting.
Yeah. And by A0?
Because he picked
Alex has
A0.
taken.
Yeah, if he picks n minus 1, he takes a n minus 1. Correct? So
yes.
This is the sub problem. So naturally, if you see, your sub problem needs to have a player also, the player who is going next. So that naturally, and you see the sub problem is a sub array. So it's a sub array and a player. So from there I formulate my DP, the recurrence as DP IJP. It basically represents the maximum that P can get from sequence I to J. So how would you write this? You would say DP 0 n minus 1 Alex is nothing but the maximum of the two choices. What are the choices? If he goes for 0, then he has A0, and whatever Bob gets from 1 to n minus 1, if you subtract that from summation A1 to n minus 1, right, that will be what Alice will get, summation AI from 1 to n minus 1 minus whatever Bob gets from 1 to n minus 1. So you can subtract that, whatever that will be what Alice will get, and plus A0. So this is one case. And the other case is if Alice takes n minus 1, so then Alex can get an minus 1 plus another expression which will be the same, like similar to this. Instead of 1 and n minus 1, you will have 0 and n minus 2. So this is one way you could go about your DP solution. Right? Is solution 1 clear to everyone? How many of you understand solution 1? Do you understand the reason behind taking summation here and subtracting? Correct. So this is solution 1. So you could do this, code it, be happy. Another way you could do it is, you could, if you want to eliminate the Bob possibility, the Bob dimension altogether, what Geetans was saying is go 2 steps, simulate 2 steps, don't simulate 1 step. So what are there are 4 choices basically, right? One choice is Alex takes 0 and Bob takes 1. Another choice is Alex takes 0, Bob takes n minus 1. Another choice is Alex takes n minus 1, Bob takes 0. Fourth is Alex takes n minus 1, Bob takes n minus 2. These are all tongue twisters, Alex, Bob. So these are the 4 choices, right? If you go 2 steps, right? So what is the maximum that Alex can make? What the maximum that Alex can make is the maximum of all these 4, right? So if this is the choice that Alex and Bob have made in the first 2 steps, what is the sub problem that you are left with? You are left with 2 to n minus 1, right? Here you are left with 1 to n minus 2. Here you are left with 1 to n minus 2 again. Here you are left with 0 to n minus 3. So find out what the maximum Alex can get from here. So let dpij represent the maximum that Alex can get. Now this is fixed. You are fixing a player here. You're saying maximum that Alex can get from I to j. And the recurrence for that would be that you would say that this is basically equal to the maximum of these 4 quantities. Let's write one of these quantities. One of these quantities is Alex takes 0, A0 plus dp of 2 to n minus 1. This is one. Another quantity, if you want to write it down, it will be if Alex takes 0 and Bob takes n minus 1, it will be A0 plus dp of 1 to n minus 2. Another is this. If you want to write another one of that, it will be an minus 1 plus dp of 1 to n minus 2. And you can write the 4th quantity also, an minus 1 plus dp of 0, n minus 3. So you take the maximum of these 4 and that will be what Alex can get. This is another solution wherein you don't have to worry about the cumulative sums, and this is how you can get rid of the requirement that a player has to go first, like the next player begins the next round. So we have gotten rid of that by simulating for even number of rounds or 2 rounds. Right? Is 2 clear to everyone? How many of you understand 2? Okay. And then there is another solution wherein you can get rid of the player's dimension altogether through the smart way, which I had discussed in the last class also. We say that dpij represents the difference between P1 score and P2 score, assuming P1 goes first. So we are saying that whoever goes first, it is his score minus the other player's score in the sequence A, I to J. So we say that this is another way you can get rid of the player dimension altogether. You talk about the difference of the score. So if you talk about, so there are 2 things here. See, we have eliminated the other guy's score by taking the difference, and we have eliminated the order by always fixing that the score is P1 minus P2. Whoever is going first minus the other player's score. So we have gotten round, if you really clearly like think at a deeper level, we have achieved these 2 things. We have eliminated the need, the need for other player score, need for deriving this player's score from other player's score, right? We were doing that in the first solution, right? What were we doing? We were saying that take the cumulative sum and subtract it, right? So that's how we were eliminating the need for deriving the current player's score from the other player's score. In solution 2, we eliminated that by simulating it for even number of rounds. Here we are eliminating that by keeping a difference. So from the difference, we can derive the current player score also. And we can derive the winner also, because the winner will have either a positive or winner will have a positive difference, right? So we can arrive at a winner also from there. The other intuition is there was a need for, if you see, when we were simulating 1 round, we were dependent on the fact that the other player goes next. So this game is alternate players game. So that requirement constraint we have taken care of by always assuming that it is the difference between P1 minus P2. Whoever goes first, his score minus the other player's score. And that's how we have generalized it and not made it specific to an order. That's basically the intuition. So if it's fine if you don't understand this, this is basically the intuition as to how we or why this works. So this is the formulation for dpij. Any questions on the formulation for dpij?
So
Yeah, sir.
तो उसमें ऐसा भी कर सकते हैं ना कि स्कोर को हटा ही दो, मतलब डीपीआईजे में सीधा ये स्टोर करेंगे कि कौन जीता उस सब एरे के लिए। तो इसका बेस केस हो जाएगा कि जब भी आई इक्वल टू जे है तब एलएस जीतेगा, क्योंकि वो एक ही एलिमेंट है तो फर्स्ट चांस में वो उठा लेगा। फिर डीपी ऑफ आई जे को कैलकुलेट करने का रिकरेंस ये होगा कि अगर डीपी ऑफ आई माइनस जे और डीपी ऑफ डीपी ऑफ आई माइनस 1 कॉमा जे और आई कॉमा जे माइनस 1 ये दोनों एलएस या दोनों बॉब है, तो डीपी ऑफ आई कॉमा जे भी वही होगा जो वो दोनों है।
मतलब उन दोनों में से अगर एक में भी, हाँ बताओ।
नहीं, अगर डीपी ऑफ आई माइनस 1 कॉमा जे और डीपी ऑफ आई कॉमा जे
होगा ना, उससे ऐसे कंप्लीट नहीं होगा कि अगर आपका इफ यू हैव आई टू जे और आपने बोल दिया कि i+1 से j में विनर आपका बॉब है, ठीक है?
हाँ हाँ
इसमें आपका विनर बॉब था और i से j-1 में भी बॉब विनर था, तो
हाँ,
आप बोलोगे कि
आई
एलेक्स
जे से
i से j में
आई
बॉब
कॉमा
नहीं
जे
जीत
में भी
सकता।
बॉब ही होगा।
नहीं, क्योंकि एलेक्स का एक्स्ट्रा स्कोर है ना यहाँ पर। अगर डिफरेंस मान लो ऐसा है, मान लो बॉब का स्कोर 5 है, एलेक्स का स्कोर 3 है और करंट इंडेक्स AI 100 है, तो एलेक्स जीतेगा ना।
हाँ 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 सही।
तो वो चीज़ आप नहीं कर सकते। तो स्कोर रखना पड़ेगा किसी तरीके से कुछ, क्योंकि इट्स नॉट ओनली डिपेंडेंट ऑन द सब एरे, यू आर यूजिंग द करंट स्कोर ऑल्सो फॉर दैट. Did you understand Utsav's question? It's a like, and why it doesn't work? And any questions on this DP formulation? The English statement of the DP? I guess you will have questions, definitely. Like at least I had questions when I understood it for the first time.
So I have a doubt on the mathematical expression for the third one.
Okay, we will come to that. Okay, but yeah, let's complete this first, and then we can take.
What was the Utsav question? I did not understand clearly.
Yeah, it's okay. Utsav, we can discuss it after the class. Okay, Swami, what was Utsav's question? So he was just saying that for IJ, why don't we just score the keep the winner and not the difference of the score or Alex's score? Just keep the winner. Who is the winner, and then take a decision. So think why it does not work. Okay. So if this is the statement how you work, then what is the step? What is the decision? You have 0 to n-1. dp of 0 to n-1 basically scores the keeps the difference between 0 to n-1 between player 1 and player 2, right? So this will be, let's say the player who is playing picks A0. So if he picks A0, he will already have a score of A0. And if you calculate for I to n-1, you will need to subtract that from this to obtain the difference. That's the first case. The other case is if the player picks n-1. If he picks n-1, it is a n-1 minus dp of 0 n-2. So you take the maximum of these two.
So
and that's
the
basically 0 to n-1. What?
So the third mathematical expression, right?
Come again?
This is expression for the dp ij p1 minus p2 formulation.
Yeah, this is for this. This is for this only. So this is how we formulate it. Why do we subtract here? See, you are basically interested in computing for 0 to n-1. So you already have A0. So think about this in this manner. Some of these will be picked by Alex. Let's mark them with green. Some of them will be picked by Bob. So let's mark them with yellow. Let's say this is what it is. Now, what is the difference between the scores of Alex and Bob, or P1 and P2? So let's say green ones are basically the ones which have been picked up by P1, and yellow ones are the ones which have been picked up by P2. So what is P1 minus P2? The P1 minus P2 is this plus this plus this minus this plus this plus this, right? So how can you formulate it in terms of the sub problem? So it is A0, and what will you get from here? From here you will get yellow minus green, right? But what do you eventually want? You eventually want green minus yellow. So you will subtract so that this and this gets added and the eventual solution is subtracted from this. So that's how you will get a green minus yellow. And that's basically the intuition behind this difference, or the reason behind this. How many of you understand this? The recurrence and the English statement as well as the recurrence relation?
Sir, why are we using max?
Why? Because that player is trying to get the maximum score for him, right? So if he tries to optimize P1, the score P1 minus P2 will be the maximum out of these two choices. That's what he's trying to do, right? The difference will also be greater, right? So consider two paths. Consider two paths. For one path, see, P1 plus P2 is always a constant.
He is getting the maximum difference.
Yeah, so that will ensure that he gets the maximum score also. The reason behind that is P1 plus P2 is a constant. So the sum of the scores are constant. And let's take two cases. So I want to prove that if P1 is greater than P2, if let's take two instances of P1 score and let's call them S1 and S2. If I say that, so let's say we get two instances, SP1, SP2. This is one instance of scores, and let's say S prime P1 and S prime P2 are another two instances of the scores. So SP1 is the score of P1, SP2 is the score of P2. This is one simulation, one round or one game. And S prime P1 is the score for P1, S prime P2 is the score for P2 for another game. I want to prove that if SP1 is greater than S prime P1, that implies, double implies, SP1 minus SP2 is greater than S prime P1 minus S prime P2. Right? This is what I have to prove both ways. Right? So you can prove it both ways.
But it also depends on SP2 and SP2 prime also.
Yeah, so the fact is that P1 plus P2 is constant. So SP1 plus SP2 is a constant. So if you have SP1 greater than SP1 prime, then SP2 is less than SP2 prime. Right? Because the sum is a constant.
So could you repeat what is SP?
We are like just debating on the fact that why is it that if he maximizes the difference between his score and the other player's score, it is equivalent to him maximizing his score. Because the question is telling him to maximize his score, right?
Yeah, yeah.
So we are just doing that more formally, mathematically. Like the intuition is the same, right? If his score is greater, then the difference between, because the sum is constant, if his score is greater, the other player's score will normally go down, right? So the difference will become more compared to a case when his sum is smaller and the other player's sum is greater than the previous instance. So that's what we are trying to do here in SP1, SP2, SP1 prime and SP1, P2 prime. ये किसी को समझ आया क्या?
Yes, sir. Sir, greedy doesn't work because we are not maximizing the difference, right?
Yeah, greedy doesn't work because you're not maximizing the difference. No, this is different. Greedy does not work because it does not work. Matlab, because we have a disprove. Like I gave you a counter, right? You cannot say that greedy does not work because, I mean, I did not get your question completely.
Sir, I mean, in greedy approach, we consider maximum of only of n minus 1.
Yeah, this is exhaustive. This is, we are not depending on A0 or AN minus 1, depending it on the entire relation, right? So this is global. This is not a local optimum that we are looking for. So this will always be correct. The other one can work, sometimes cannot work, because we will talk about it in detail when we talk about greedy algorithm. But the essential idea is that we are trying to maximize this step. But that does not mean that you will get a global maximum, because it can happen that the other steps become much more smaller because of your choice that you made here.
Yes, sir. Got it.
That's why greedy does not work there.
Okay.
But in some problems, it will always be the case that no matter what happens, if you make a greedy choice, it will always work. It will never lead to a scenario that will compromise your future selections. So for them, greedy works out well. So we will look at questions of that type also. But this is clear to everyone? Can I move ahead? Yeah, we will talk about the base case. So now you see what is the sub problem here. The sub problem is a sub array, right? And what are we doing here? When we are computing for ij, we are using I plus 1 to j minus 1 or I to j minus 1, right? So we are using a subarray of length 1 less than this subarray. If this subarray is of length n, we are using a subarray of length n minus 1, the result from there, right? So this is a length dp. This is very similar to the longest common palindromic substring subsequence that we did. So this will be a length dp. So what will be the base case then? The base case will be the smallest subarray. What is the smallest subarray? Subarray of length 1, right? So in that case, the difference will be the score itself, right? Because that score minus the other person's score, other person will get a 0. Right, Rishabh? So that will be the base case. And then you can construct for subarrays of length 2 first, then subarrays of length 3, then subarrays of length 4, and so on. Correct? Karan, do you understand this? Everyone understands this? Yeah, base case for length 2, you can do it. It will be the maximum. I mean, the max minus the min, the greater minus the, that's not, you can do that. So if you understand that, let's quickly look at the code. Or do you want to try the code on your own? I have already shown you how to simulate length arrays. It will be similar, right? Let's code it if you really want. Others, do you want to try it on your own, or do you want me to? Yeah, so try it. Now that you know how to go about solving for length arrays, I showed you one solution, right? The longest palindromic substring subsequence. So try it from here. Write down for the smallest subarray and move on to the biggest. So that is another problem on the length dp, wherein you have an explicit decision that you can make, and this is how you will go about doing it. All clear so far? No issues? So then we can start with matrix dps. So that's pretty much about length dps. This is how you go about solving length dps. Decisions remain the same. Like I have talked to you about 4 types of decisions roughly. Those are like primarily the main decisions. No, not matrix means the input question will give you a matrix. You will see. So let's talk about dynamic programming on matrices. So in these questions, roughly what happens is you are given, in these questions, roughly what happens is you are given a matrix in the question. So far, whatever questions we have done or whatever theory we have seen concern or pertain to one-dimensional matrices, one-dimensional arrays. Typically, you were given sequences, 1D sequences, either 1 or 2, and you used those sequences in your DP sub-problem formulation as well as the eventual solution. Now we will look at questions wherein you are given matrix as problems. So in the problem statement itself, you are given a matrix. And what kind of sub-problems can you form? And how will you go about solving those questions? So again, so typically you have order n square solutions and order n cube solutions. All these are 2D DP. So we will look at that. So let's look at that. One classic question. let's try this min path sum. How do you go about solving this? 64.
Sir, we can check to get to any index I comma j. What is the, like, as we can arrive only from the left or the top, so we can get the minimum of the either. And the
Right.
base cases would be along the rows, like row 0 and column 0. Just sum up till the end, and so that's it.
Yeah. So matrix DPs are relatively easier, and the only reason they are much more easier than one-dimensional DPs is because the decision is given explicitly. Here you have a decision that is explicitly given. So how do you go about? This is the fundamental reason why matrix DPs are much easier. Your decision is explicit. What is the question here? The question is that you are given a matrix and you start at a given index 0, 0, and you want to reach a given index, which is n minus 1, n minus 1, or m minus 1, n minus 1. You have to find the path which costs the minimum to reach from here to here. But at every step, you can only go take two choices. You can either go right or you can go down. So what is the decision? The decision is very simple, right? He can either go right or he can go down. Correct? So what is the sub problem now? Let's think. If he goes right, what is the sub problem that he is left with? He is left with this as the sub problem. Right? So the sum will be A0, A0, 0, whatever that matrix is, plus whatever you get for this, the same problem for this matrix. Why are these cells not included? Because from here he cannot come here, because he can only go right and go down. There is no going back. Correct? What if he goes down? If he goes down, then what is the sub problem that he's left with? He's left with this sub problem. Right? Do you understand this? That if he makes this choice, this is the sub problem that he's left with. So what is the relationship between this sub problem and the actual problem? If you see, these are all, what is the relationship? Tell me. No, he cannot come back. That's it. He cannot come back.
अगर उसने राइट लिया फिर से राइट लिया और फिर से राइट लिया तो
हाँ
वापस
यहाँ आ गया वो, उसके बाद वापस आके फिर यहाँ से जाएगा, मतलब ये पाथ एग्जिस्ट
अच्छा
नहीं
अच्छा
करता है,
अच्छा,
वो यहाँ से
मतलब
स्टार्ट थोड़ी
हाँ
करेगा
हाँ हाँ,
वापस।
ओके ओके। नहीं मुझे लगा उस मतलब उसके रिलेटिव राइट, तो वो एक बार राइट फिर से राइट लेगा तो वो नीचे आएगा, फिर से राइट लेगा तो उल्टा हो जाएगा।
नहीं 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 वो नहीं। So what is the sub problem? If you see, this is very easy. Aren't these all suffix arrays? थोड़ा सा और छोटा है ये, सब मैट्रिक्स भी नहीं है. These are suffix arrays of the original array because this is fixed. What will be the suffix arrays of a matrix? Just extend the analogy from prefix arrays. What are the suffix matrices of a matrix? This will be one suffix matrix. This will be one suffix matrix. This will be one suffix matrix. Right? This will be one suffix matrix. This will be one suffix matrix. This entire thing will be one suffix matrix. This will be one suffix matrix. This will be one suffix matrix. Right? These are all suffix matrices of the original matrix. So aren't these sub problems suffix matrices of the original matrix? How many of you are able to see this? So it's just the 1D equivalent if you really think. 1D में क्या था? 1D में when you were at a given cell, depending on the choice, you were left with a prefix array, or if you start from the beginning, you were left with a suffix array. यहाँ पे भी वही कर रहे हो आप. From a given cell, you are making a choice and you are left with a prefix or a suffix array. तो बहुत easy है ये. This is just the 1D equivalent. So now the next question is, if you know that these are prefix or suffix matrices, then how do you represent them? So 1D का तो आपको पता है कि prefix or suffix matrix, let's say you are going with suffix matrices. Suffix matrices can be represented by a starting index. यहां पर भी कैसे होगा? Just a starting tuple. Correct? So इसलिए हमारा DPIJ होता है. हमारा DPIJ इसलिए नहीं होता है क्योंकि हमारे पास मैट्रिक्स है. Are you getting the difference? Like the point that I'm trying to make here. Just because it's a matrix doesn't mean that your DP array will be a matrix. Here the DP is a matrix because you are going for all prefix suffix matrices of the actual matrix. And every prefix suffix matrix of an actual matrix can be encompassed or can be represented with a starting index or an ending index. And that's why we say that our DP is a 2D vector or a 2D array. 2D array IJ in which DPIJ represents the minimum path sum or the problem whatever you are solving for the suffix array starting at IJ. You are finding DPIJ for the suffix for the matrix IJ to n-1, m-1, n-1, that matrix, assuming you start at IJ. I mean, you will start at IJ only. That's the question. Basically, you always start at the top right corner. So that's basically the meaning of this. So we have done two parts. We have made the decision. Decision was explicit. It led to suffix sub-matrices. You can call it suffix sub-matrices. These are not general matrices. General matrices, there will be n to the power 4 general matrices. This will be a general matrix, sub-matrix within a matrix. But this is not a prefix matrix or a suffix matrix. This will be a prefix matrix. This will be a suffix matrix. So these are after we make decision, we see that the sub-problem is a suffix sub-matrix of the original matrix. And based on that, we have a recurrence. The recurrence is pretty easy. You know that it is A00 plus DP of, now you have, once you made this, what are the choices? You are left with this part. So this submatrix, how can you relate? How can you represent? You can represent it with 0, 1. So you say plus DP 0, 1. Another path is if he takes down, if he goes down, then this is the sub matrix that you are left with, and this can be represented by 1 0. So plus dp of 1 0, and you take the minimum out of these two, because you are looking for a minimum path sum. So that's the recurrence we come up with. Once we know the recurrence, we know we try to understand the sub problem. We have already understood the sub problem. These are suffix matrices, sub matrices. So we have understood the sub problem. Cool. Now let's determine the order in which you can fill it. Just extend the analogy from 1D. Why is it row wise, Akansha? What is the order? What was the order for a suffix subarray? The smallest suffix array, right? The smallest suffix array was this. Then the next biggest suffix array was this. The next biggest suffix array was this. तो सेम चीज आपको यहां पर भी करना है. 2D मैट्रिक्स है तो स्मॉलेस्ट सफिक्स मैट्रिक्स ये होगा. द नेक्स्ट सफिक्स मैट्रिक्स क्या क्या होगा? ये होगा और ये होगा. Right? So you can fill from the smallest submatrix to the largest submatrix, but populating but what you are saying is also correct. You can fill it row wise also. How? You can just see. Now all the suffix matrices, there are n square such suffix matrices. So for all those n square, I can draw the subproblem space, right? So this is my subproblem space. So what is the subproblem space representing? You have a given starting index. So you can denote the row number here, and you can denote the column number here. So when you are here, let's say 1 1, you are saying that starting from 1 1 or from 1 1 to m minus 1 n minus 1, what is the minimum path sum? So that will be stored in this cell. So what are you using for this? What are you using? You have two decisions. From here, you are using 1 2. So 1 2 is this, and you are using, so you are using this subproblem. So you are using 1 2, and you are using, when you go down, you are using this subproblem, which is 2 1. What is 2 1? 2 1 is this. So for computing this cell, you are using these two cells, right? So you can fill it in this order also. Right? So you populate the sub matrix for row number n minus 1 and column number n minus 1 first. This is basically you are populating this sub matrix first. Then you populate the sub matrix for this, which is row number n minus 1 and column number n minus 2. So row number n minus 1 and column, so you are populating this sub matrix now. Row number n minus, no, you are populating this sub matrix. Row number n minus 1, column number n minus 2. Then row number n minus 1, column number n minus 3. So you are populating this submatrix now, suffix submatrix. So on till here. Then you go here. So you are now populating n minus 2 and n minus 1. So this is n minus 2 and n minus 1. Then the next is you are populating this. Next you are populating this. Next you are populating this. Then you are going up again. You are populating this, populating this, So these are all suffix matrices, right? That you are populating. Is this clear? How we are going about populating the suffix matrices, the order? So we are filling it row wise only, what you are saying, but this is the order. So we are populating this, then we are populating a suffix matrix of length 2 like this, then 3, length and 4, then again coming back to length 2, length, now length 4, then length 6, then length 8, right? So when you are here, you are populating this suffix matrix. When you are here, you are populating this suffix matrix. Is all this theory clear to everyone? Karan, does it make sense? So it's very analogous to 1D suffix matrices. Pradyum, is this clear? Like, are you able to see the sub problems? Get a feeling for the sub problem. That is very, like, I cannot tell you how like underrated that quality is. Get a feeling for what sub problem you are left with. Don't just go ahead with a mathematical representation to begin with. Understand that it's a prefix array or a suffix array. Then go ahead with a representation. Mathematically, you can represent any sub problem. Once you get a feeling for the sub problem, you will automatically get the order also in which you can go about filling it. So very simple then. And then what is the base case? The base case is for this. For any cell, we are using one from the right and one from the down. So for these boundary cells, we will be using one from the down. We can get it. From the right, we won't get it. So we have to take care of that case. And this will be the base case. For this, the minimum path sum is just the value of this. Right? So let's see this in action now. So let's see. So we are just calculating I and j. We have our sub problems are suffix sub matrices of the original matrix, and I will fill it from right to left, bottom to up. That's the order in which I will go about filling it. The base case is dp of, let's first define the dp. So it's the same matrix. You have an m by n, you have m into n such possible suffix arrays, right? Let's all int max, let's initialize it to, which means that by default there is no path. Base case is dp of m minus 1 n minus 1, which is basically grid of m minus 1 n minus 1. Right now fill. So filling, you will go from m minus 1 to 0 and again n minus 1 to 0. Just the base case, skip the base case because you have already filled it. Dp if I is m minus 1, just skip it.
Sir, why can't you iterate from I is equal to m minus 2 and j is equal to n minus 2?
Then you will have to fill all the boundaries, right? The last row and the last column completely. I have not filled the last row and the last column. I have just filled the last cell. Correct?
Yeah.
So
So that's
what that base case line number 13 does? Like,
so it is telling you that the minimum path sum from m-1 n-1 to m-1 n-1 is basically the value of the cell. For that suffix subproblem, it is this. Right?
yeah, okay.
So now you take care of the cases. You have two possibilities. So if I plus 1 is less than m, then you can take this. So dpij is minimum of, or you can just keep taking the minimum because you have initialized it to int max. So you have minimum of whatever it has, comma grid ij plus dp of I plus 1j, and the second one is if j plus 1 is less than n, then you have dpij is, just continue taking the minimum. And yeah, that's it. I think you can just return dp of 0, 0. Okay. Yes, the minimum length of the path. Okay, Karan? The recurrence will be the same, Aman. The recurrence will not change no matter if you go from top to bottom or from bottom to up. Let's do a question when we will go from top to bottom also, okay? And I will try and explain the essential elements of a bottom top down approach also. The recurrence will be the same. Just to answer your question, the recurrence remains the same. This is still the recurrence. So the subproblem, whatever the subproblem is, that will go in the function prototype. That's the only difference. It's not. हाँ, तो उस केस में आपका how I plus 1 will exist if I go from top to bottom. We will see. Basically, I will explain you top to bottom. Don't worry. We will do a couple of questions today only. I have that in the plan. Okay, and
Sir,
then we can come back to this.
What grid ij is doing in line 24 and 27?
We are just taking that current value will also be there in the solution, right? In the path, the minimum path, starting from that ij. So we're just adding that to whatever we get from the right or from the down.
Okay.
Can we write I and then take, just be careful. You have to fill the last bound, the last column and the last row also. So just make sure that those are not skipped. हाँ, मैं कर दूंगा, अच्छे से कर दूंगा, बट बॉटम अप करना ही चाहिए इन माय ओपिनियन. एवरीवन शुड डू बॉटम अप. टॉप डाउन में लोगों को ज़्यादा क्लैरिटी नहीं होती, फिर भी कर देते हैं क्वेश्चन तो हो ही जाता है. बट बॉटम अप में जितना क्लैरिटी चाहिए होता है in order to completely solve a bottom-up question is much more than top-down. Top-down, once you have the recurrence, it's very easy. You don't really need to think about how the sub-problems are evolving or how you are computing. Top-down में वही benefit होता है. But in my opinion, everyone should do bottom-up. बहुत चीज़ें समझ आती है आपको bottom-up में, जो top-down से समझ नहीं आती है. Once you do an analysis bottom-up. We will do questions on top-down also. Is this clear to everyone?
सर
Yeah.
सर ये DPIJ तो चेंज एक बार ही होगा ना, मतलब इसकी वैल्यू तो एक बार चेंज होगी ना?
2 बार होगी ना. देखो कोई भी इंटरनल सेल के लिए 2 बार चेंज होगी. एक बार i+1 j के लिए, एक बार ij+1 के लिए. दोनों में से आप दोनों का जो मिनिमम होगा वो लोगे. और बाउंड्री सेल्स के लिए एक ही बार चेंज होगी. अगर लास्ट रो है तो सिर्फ राइट वाले के पे डिपेंडेंट है, और लास्ट कॉलम है तो सिर्फ नीचे वाले पे डिपेंडेंट है.
ओके.
बट हाँ, तो वो सारी चीजें आप ध्यान रख लेना. मतलब जब भी आप ये एंड लगाओगे, अगर आप ये बोल रहे हो ना व्हाट इफ आई राइट दिस, और यहाँ पर मैं ये मिनिमम ले लूँ, इसकी जगह ये लिख दूँ, ये वाली चीज लिख दूँ,
हाँ.
तो नहीं होगा उससे. आप एक बार देख लेना, केसेस छूट जाएंगे. मतलब बाउंड्रीज तो छूट ही जाएगा आपका, क्योंकि बाउंड्रीज के लिए ये ट्रू नहीं होता है ना कि दोनों चीज लेस देन m और लेस देन n है.
यस.
तो फिर बाउंड्रीज को आप यहाँ बेस केस में इनिशियलाइज कर देना पहले यहाँ पर, तो भी हो जाएगा. बाउंड्रीज को एक्चुअली आप एक सिंपलेस्ट तरीका तो यही होता है कि आप बाउंड्रीज को यहाँ इनिशियलाइज कर दो, यहाँ फॉर लूप चला के बाउंड्रीज को इनिशियलाइज कर दो, और फिर इसको m-2 से m-2 और n-2 से स्टार्ट कर दो. फिर तो आपको कभी ये इशू ही नहीं आएगा कि i+1 m से कम है, j+1 n. ये हमेशा ही रहेगा ट्रू, बिकॉज यू हैव टेकन केयर ऑफ दैट एक्सप्लिसिटली. तो दैट इज वन वे यू कैन go do it. I just try to do it in the same loop most of the time. So तब उस टाइम पे you have to think on these cases. ठीक है, let's move on. Let's try another question on matrix. Similar question. Let's try unique paths. Unique path is also a simple question. You can try it on your own. I think we can do Dungeon Princess. That question is good. Try 62 on your own. I think I have pasted some questions on Slack. I will paste more today. This is also similar. Let me share the link. हाँ वो करेंगे, वो बहुत अच्छा क्वेश्चन है. मतलब वो गूगल बहुत पूछता है डंजन गेम. हाँ प्रद्युम, अरे आप लीड कोड का पूरा 200 कर डालो प्रद्युम. आपको बहुत एंथु है डीपी का ना, पूरा कर डालो. बहुत इजी है, ज़्यादा टाइम नहीं लगेगा. बैठोगे ना करने तो 200 क्वेश्चन है अभी लीड कोड पे डीपी के. उसमें से 150-160 क्वेश्चन तो आपको प्यार से हो जाएंगे. 20-30 में फंस जाओगे, वो थोड़े ज़्यादा टफ हैं. कुछ हैं वैसे. हाँ इंटरव्यू बिट बहुत टफ है. इंटरव्यू बिट का डीपी एक एक क्वेश्चन अच्छा क्वेश्चन है, एक एक क्वेश्चन करने में टाइम लगता है. लीड कोड इजी है डीपी का. इंटरव्यू बिट का डीपी और ग्राफ सही में टफ है, और अच्छा भी है. एक्चुअली करना तो दोनों ही चाहिए आपको. फ्रॉग जंप वाला मैं कराऊंगा, वो आज प्लान में. वो टॉप डाउन करना है, इसलिए वो प्लान में. फ्रॉग जंप करना है आज. हाँ आज करना है, फ्रॉग जंप करना है, क्योंकि वो मेरे प्लान में. लीड कोड हाँ बिना डीपी के भी हो जाएगा वो फ्रॉग जंप. ठीक है, ट्राई दिस यूनिक पाथ क्वेश्चन. दिस इज ऑल्सो not very tough. We will do dungeon princes. What was the number? आशीष ने बोला था ना. Yes, 174 है क्या? हाँ, तो वही करना है. We will do that question now. Unique path is same basically. From a given cell, you have two types of paths. So in unique path, the decision is, what is the decision? Can anyone tell me the decision in the question, unique path that we?
Yes, sir. Like.
Yeah.
Okay, so what we can do is like the similar question. In this case, we can also like come from the top of the cell or from the right or from the left of the cell. So just add up the.
What is the decision
cases.
in English? वो ठीक है, add up the cases ठीक है.
Decision. Okay, let me frame it.
Aren't you looking at the first line in the path, like the first in the eventual path? What are we saying? You are saying that all possible paths from 0 0, so you have a 0 0, you have this. So all possible paths from 0 0 will either this, if this is the solution set, all possible paths from 0 0 will either have 0 1 as the first two nodes, 0 0 0 1 as the first two nodes, and then it will have other values. So this is one set of paths, right? All of them will have this as the first path, and the other is you will have 0 0 to 1 0 as the first edge in the path. So that is another set of solutions, right? So our decision here is that we are looking at the first solution, the first path, first edge of the paths, of all the paths, and we are saying that there are two types of edges in the paths. You have this type of an edge 0 0 0 1, or you have this type of an edge 0 0 1 0. So the total solution is this plus this. So what is the total number of paths you can get from 0 1 to n minus 1 n minus 1? Whatever you can get will be the size of this, and whatever you can get from 1 0 to n minus 1 n will be the size of this. So you are saying that at this cell you will basically take the sum of this and this. So the decision is again similar. You are looking at the first solution of the result. Right? This is one interpretation or one way of thinking about the recurrence relation that you guys write. There could be more ways of interpreting the same recurrence relation, right? So if somebody asks you, if a layman asks you to explain the solution, this is how you should explain कि ये दो तरह के paths हैं, तो ये path plus ये path होगा basically. Correct? Does this make sense? Do you follow this? Guys, are you there? Are you able to hear me? कभी कभी मेरे को लगता है आप लोग सब सो गए. There is a simple math formula also for this, Aman. You're right. वो कैटेलन नंबर ही होता है, वो कैटेलन नंबर है वो सनी से पूछना, सनी को मैथ आता है, मेरे को नहीं आता है मैथ। सनी जब मैथ पढ़ाएगा ना तब उससे पूछ लेंगे। कैटेलन नंबर वाले ही है वो।
Sir, in the question example 1, I can't understand it. Could you explain it?
Which example 1 you want me to explain? Let me open it. Unique path we are talking, right? So if you have a 3x2 matrix, Jadav, this is the matrix roughly, right? This matrix, 3x2. So what are the paths? You can come like this. You can come like this, right? You can come like this. You can come like this. तो वही लिखा हुआ है, right down, right down, right down, right down, right. These 3 paths, right? You can only go right and down. You cannot go up or you cannot go left. Okay, so this is basically unique paths. Let's try 174 now.
Sir, in the previous question, can we do state space optimization with percentage 2, modulo 2?
What do you think?
I think we can.
Yes.
Because we are only using
previous. You are just using the previous row. You can do it.
Yeah.
So let's do 174 now. The same thing, Karmanya. See, when you are at a given row, you are using the value from the previous row and the current row, one of the previous values from the current row, right? Yes. So you can just keep these 2 rows. Like, were you there day before yesterday when we discussed the optimization?
Yes, sir.
So you could just modulo on the length, the row number.
Achha.
So do a modulo 2 on I and j both.
Okay, just maintain 2.
Yeah, just maintain 2 and keep taking. When you take dpij, just take dpi modulo 2, j modulo 2. Which will ensure that. So what will happen is, see, so here when we are at a given cell, we are using the result of this and this, right? So you just need this current row and this row. So you can get away with just these 2 rows, this row and this row. Correct? So what you could do is, instead of keeping the entire DP matrix, what you could do is you could just keep 2 rows. So how this entire DP matrix maps to those 2 rows, I will show you. So let's say you are taking what the picture says, 1, 2, 3, 4. So let's take, say 5, you have 5 rows in the eventual matrix. You are only taking 2 rows. So you will have 0 and 1, okay, and all the columns. Okay. So what you will do is, every time you write dpij, in place of that,
we take
you can write dpi modulo 2 j. Okay, what happens with that is, when you are filling for row 4, right? You are filling in this order from right to left. So row 4 will map to 0, right? Because 4 modulo 2 will be 0. So it will map to this. So you will have these values populated.
Okay.
Now, when you go to 3, you will fill them in this order. So these 3 modulo 2 is 1. So these values will start getting filled. Right? So now whenever you are at a given cell, you can use the previous 2 values. You have them at your disposal. Okay. So you are done with 1. Now once you are done with 3, you are at 2. So 2 modulo 2 is 0. So now you will start replacing these again. So you have a previous value, then just the immediate previous value, because it was an odd column, odd row, you already have it and you are at a current even row. So you can use again. So now this will get replaced. In the next step, this will get replaced.
It will get replaced or added onto the original value?
It will get replaced, right? You are doing, why will it get added?
Yeah,
like
it will get plus.
Yeah, and you'll have to reinitialize it. You are doing a modulo 2, right? So yeah, I mean, you will have to make sure it does not get added if at all you are just doing a plus equals from. If you've just initialized it to 0 and you are just doing a plus equal every time, then it will get added. So you have to, at the beginning of every iteration, beginning of when you are here, basically, when you are starting out an iteration for the row, just clear it. Like do something about it.
Okay.
Right? So that's how you obtain optimization for this. So this is an order n solution then in terms of space. And time it is mn. Yeah, let's do this dungeon game. This is 174. I will paste the link as well. This is not very tough. I don't know why this is a hard question. How do you do this? It is similar. It's just that you have to take care of cases here. Yeah, the decision is same, Bhagya, you're right. But you have cases. That's why it is tough. This is Google's one of the favorite questions that it used to ask a lot when Google was young. Yeah, the decision is the same. हाँ, foo bar में है. There are cases, Utsav. It's not as simple as just taking the minimum, because the constraint is that at any point the knight's score health cannot drop below 0 or cannot drop to 0 or less than 0.
Sir, but why it initially in the example given it's -2 for knight?
Where is it -2 for knight? -2 is it's not the initial health. You have to determine the initial health that he needs. -2 is if he steps onto the cell, he will lose 2 health points. If he
okay.
on a cell with +3, he will gain 3 health points.
तो मतलब एक पाथ में जब वो ट्रैवर्स कर रहा है तो उस पाथ में जिस भी पॉइंट पे मिनिमम आएगा उस पाथ का वो मतलब अगर उस पाथ से उसको जाना है तो स्टार्टिंग में उतनी हेल्थ चाहिए ना, अगर वो लेस देन 0 है.
मतलब आप बोल रहे हो उस पाथ में जो अगर वो लेस देन 0 है, उस पाथ का जो मैक्सिमम है आप बोल रहे हो वो
नहीं उस पाथ पे आप ट्रैवर्स करो और ऐड करते जाओ तो मतलब जो भी करंट सम होगा उसका मिनिमम करते जाओ, मतलब मिनिमम ऑफ करंट सम कॉमा न्यू करंट सम, ऐसा करते जाओ। तो इस क्वांटिटी का जब भी मिनिमम आएगा नेगेटिव अगर वो है तो उतने से स्टार्ट करना पड़ेगा,
उससे एक ज़्यादा मतलब।
हाँ उससे एक जगह।
बट बीच बीच में नेगेटिव भी आएंगे ना आपको, नेगेटिव्स को आप कैसे, हाउ विल यू टेक केयर ऑफ दैट?
हाँ तो
बीच
इसीलिए
में
तो मिनिमम
पॉजिटिव्स भी
लिया
आएंगे,
ना।
बीच में पॉजिटिव्स भी तो आएंगे।
हाँ तो वो बीच, अच्छा तो मतलब वो
पॉजिटिव
उतना
में
गेन
आप,
कर ले।
हाँ उतना पॉइंट चालू, उतना पॉइंट वो ऑप्टिमल नहीं होगा ना फिर। मतलब आपको अगर अभी सीधा केस इज, so the case is कि if you are at a given cell, let's say you are here and here you have a positive score, let's say you have a 4 here, let's say from here you need at least 3 health points. So from here you can start with 1 health point, right? Okay, from here, correct? मिनिमम
वो 4 काउंट नहीं होगा क्या?
तभी तो वो जब यहाँ पर वो 1 से स्टार्ट करेगा तो उसको 5 हो जाएगा उसका यहाँ पर, तो जो वो जब यहाँ जाएगा तो उसके पास 5 रहेगा, तो इट विल बी एबल टू ट्रैवर्स दिस पाथ बिकॉज इट नीडेड 3 हेल्थ पॉइंट्स।
तो
माइनस नीचे नहीं कर सकते आप, -1 हेल्थ पॉइंट से थोड़ी स्टार्ट कर सकते।
नहीं वो
0 से भी नहीं कर सकते।
ये -3 होगा ना जो 4 के बाजू में है वो।
हाँ मतलब मैंने पूरे पाथ के लिए बोल दिया, -3 है मान लो। हाँ
हाँ तो वो 1 से स्टार्ट, हाँ सही है, बट मैं बोल रहा हूँ कि वो पाथ में अगर आप क्यूमुलेटिव सम करते जाओ उस पाथ का, तो वो क्यूमुलेटिव सम की वैल्यू जहाँ पे मिनिमम आएगी वो मतलब वही मिनिमा होगा उसका।
क्यूमुलेटिव सम की जो मिनिमम आएगी वही मिनिमा होगा उसका।
उतने से उस मिनिमम, अगर वो नेगेटिव है तो उसको आप पॉजिटिव कर दो और +1 कर दो। अगर -3 आता है क्यूमुलेटिव सम का मिनिमम तो 4 से स्टार्ट करना।
ठीक है, तो आप क्या करोगे, तो सारे पाथ्स निकालोगे और हर पाथ के लिए
नहीं जैसे हमने मिनिमम पाथ सम में किया था सेम करेंगे। मतलब एक सिंगल एलिमेंट से स्टार्ट करेंगे और फिर उसको बॉटम अप अप्रोच जैसे करते जाएंगे।
तो स्टोर क्या करोगे आप, मतलब व्हाट डज इट
स्टोर करेंगे उसका जो क्यूमुलेटिव सम है उसका मिनिमम, मतलब मिनिमम ऑफ क्यूमुलेटिव सम कॉमा क्यूमुलेटिव सम प्लस AI, ये स्टोर करेंगे और ऑल द पाथ, सब पाथ्स का मिनिमम, इसका भी मिनिमम।
I got what you're saying. ऑल द सब पाथ्स का मिनिमम चाहिए या मैक्सिमम चाहिए?
मिनिमम ना,
मतलब केसेस हो जाएंगे ना, अगर आपके पास 3 पाथ्स पॉसिबल है कोई एक पर्टिकुलर पॉइंट से, और इस पाथ में सबसे छोटा जो क्यूमुलेटिव सम पॉसिबल है वो सपोज करो -3 है, और
हाँ मैक्सिमम चाहिए
यहाँ पर मान लो आपका 2 है,
नेगेटिव में।
तो सारे नेगेटिव सारे पॉजिटिव मतलब केसेस हो जाएंगे फिर।
हाँ केसेस,
वो फंस जाओगे आप वहाँ पर।
हाँ पॉजिटिव है उसको 0 मान लेंगे, ऐसा नहीं कर सकते, ऐसा केसेस हो जाएंगे।
मैक्स भी नहीं कर सकते आप, मिन भी नहीं कर सकते, मतलब सोचना पड़ेगा क्या कर सकते हो। Any other idea? So store what the question is telling you. Why do you want to store anything else? Just store whatever the question is telling you. Store the minimum DPIJ should represent the minimum health point that the prince should have, such that if he starts from IJ, he is able to find his princess, who is at n-1, n-1. Just store that in DPIJ. How can you compute it? So Karan, it could be minimum, it could be maximum, depending on whether you have a negative cumulative sum or a positive cumulative sum. So think about it. So if you have a set of paths wherein you have -2, -3 and -5, so yahan par you should start with 6, right? And if you have a set of paths, let's say 2, 3, 5, yahan pe you should start with 1. If you have a set of paths, let's say -2, 3 and -5, every question can be bottom up or top down. We will do it bottom up only. So think about when you are at a given index, what is the minimum health score that you need? So DPIJ, yeah, something like that, represents the minimum health score that the prince needs to reach m-1 n-1 from ij. So that is DPIJ. How can you compute this? Now there are cases. Let me give you a hint. You can have the current cell as positive or negative, right? So you could have a -3 here, you could have a 5 here. You will have, and the other set of cases is you can get a positive value from here or a negative value from here or from here. So there will be 4 cases. I mean, you can write all of that in 2 lines. That's another thing. So this is positive, negative for ij. And this is for negative, positive for I plus 1j. Similarly, you will have to do the same thing for ij minus 1 also, ij plus 1 also. So what are the cases? Let's take cases. Let's take the simplest cases first. Let's say you have a current positive value and you get from I plus 1 to n minus 1, whatever you get is also a positive value. What are the cases in that? This cell could have 8, and what you get, which is the minimum that you need from I plus 1 to m minus 1, n minus 1, that could be less than 8 or greater than 8, right? So let's say it is 5. So what does that mean? That means you can start with a health score of 1 here. You will be able to reach. Why? Because once you start from a health score of 1, you will get a health 8 point. So you will get a health score of 9 before you reach here. And from here, you know that the minimum health that is needed is 5. So you will be able to traverse. Correct? Is this first case clear to everyone? First case is, I'm saying current value is positive. Second, the neighboring value is also positive, and the neighboring value is less than the current value. If the neighboring value is less than the current value, then you can start with a health score of 1. That's the simplest case. Why? Because this health score is much more. Right, Tushar? Others, do you understand this case?
Then why your index then it has -3 then?
अरे I have not indexed, इसको 8 लिख लो यार. I'm just taking.
Yeah, okay.
0 लिखा हुआ है. You cannot have a health score of 0 at any point for the print. It's just a constraint that's given in the question.
Sir, is it like at any index which is negative we should not go, or the cumulative that negative?
Yeah, the cumulative with that should not go less equals 0.
Okay.
ठीक है? So this is 1. 8 will be added, but it's just there in the question, Geetans, like, और कुछ नहीं है उसमें. You cannot have the king, the prince. Think about it in this way. Prince is jumping onto that cell, right? So to jump also he needs the energy, even though he is not spending energy. It's just that with 0 he is not alive. At any point, as soon as his health becomes 0, he dies. So it's just a constraint in the question. Like, I understand what you're trying to say, but that's how it is in the question. So, okay. So this is the first case. What is the other case? The other case could be that this is smaller.
Sir, in positive case, why there again 2 cases emerged?
Because you could have a greater, so you could have a requirement which is more than what you have at the current cell, or you could have a requirement which is less than what you have at the current cell. Depending on that, your initial health score will be calculated, right? So one case is if you have a requirement of 5 and at the current cell you have 8. So then you can just start with 1. Correct? That's the first case. The other case is if the current cell is, let's say, a 5 and the requirement is that of an 8. So
Okay.
then you can do 8 minus 5 plus 1, right? So you can start with 4 here, and that will be the minimum that you need, right? Everyone understands this case also?
Sir, why we are adding +1 then?
Because once we jump onto the next cell, if you come with 3, you will get a 5. So you will have 8. You cannot have, right? And from the next cell, your requirement is that of an 8. So there will be a point when you can get to a score of 0, right? Health score of 0. You cannot get a health score of 0.
Okay.
So these are the 2 cases basically. So my dp of ij is always greater equals 1, right? Because it is the minimum health score that I need to in order to reach from ij to n-1, m-1, n-1. So it is always positive. So these cases are actually not there. It's just these 4 cases that the current value can be positive, the current value can be negative. If the current value is positive, you have 2 cases. So I just told you current value. For current value positive, I told you there are 2 cases that you can have a value of I plus 1j, which is greater than the current value. Let's call it CV, and a case wherein you could have it less than the current value. So we said in this case, if it is, what you get from I plus 1j is greater, then you could take the difference and you have difference plus 1. And if this is the case, you could start with 1. This is the first set of cases, right? The second set of cases is if the current value is negative. So just work out the other case. What is, so let's take 2 cases. You have a -8 at the current cell and you have a requirement of 5 from the neighbor, What will you go ahead with here? -14, right? So you will go ahead with 5 minus -8. plus 1. So if the current value is negative, and so you have a difference plus 1 in this case. What about the other case? If you have a minus 5 here, and let's say you need a requirement of 8 from the, what will you do? It's the same thing again, right? It will again be 14, right? Correct? So for the current value as negative, you will always have a requirement of diff plus 1. And if the current value is positive, depending on whether the requirement is greater than the current value or less than the current value, the minimum will be diff plus 1 or 1.
So could you repeat current value? If current value is positive, why it is taking 1 for less than CV case?
For less than CV, think about this case. If your current value has 8 and you have a requirement of 5, you can just initialize, the health score could be 1. You jump to this cell, you get 8 points. So your health score becomes 9. Now you have a requirement of 5. So you can fulfill that.
Okay.
5 और -8 में, so your -8 अभी करंट सेल का वैल्यू है, 5 का रिक्वायरमेंट है, तो 14 से स्टार्ट करोगे तो हो जाएगा. यहाँ पर कूदोगे तो 6 बचेगा और रिक्वायरमेंट 5 का है, तो 1 के गैप में हो जाएगा. तो नेगेटिव के लिए इट्स 1 प्लस diff, पॉजिटिव के लिए दीज आर द केसेस. So just 3 cases you have, in fact just 2 cases you have, 3 cases for a given I plus 1j, and you will have 3 cases for ij plus 1, and then you take the maximum or the minimum of these two. So all these cases you can together write. Can I say that these cases are nothing but maximum of 1, 1 plus diff? All these 3 cases, I am saying you can combine all these together in this line. So yeah, that's it basically. So use that. So let's see the solution for this. So again, we will do it bottom up. The sub problems are again suffix arrays. So suffix arrays are again suffix sub matrices or sub problems in this case as well. So you will need a matrix size m by n. The initial health, let's see, let's initialize it with 1 to begin with. Or yeah, let's see, we will have to take care of cases. So let's begin. So you are going from the right, left, the same order that we used in filling the previous question. We are using the same order. So going from m minus 1, 0 to n minus 1, 0. Now you have cases here. First, let's take care of the base case. The base case is if I is m minus 1 and j is n minus 1. So in that case, what is the minimum score? The minimum score is, what is the minimum score? Max of Can you tell me what is the minimum score? So if you have a negative number, it will be 1 plus the negative number. If you have a positive number, it will be 1. Yeah, 1 minus grade ij. So this will take care of the base case. Now let's talk about the other cases. I mean, you could name it. So you have dungeon. If I plus 1 is less than m, then you can go ahead with the I plus 1 case. So you can actually initialize it with, you want to find the minimum, initialize it with the maximum possible. So maximum of 1 plus, yeah, so that's the point. It works with all the cases. So you start with, it'll be 1, either the maximum of 1 or the difference, right? So what is the difference? The difference is, so you are taking the difference, this minus dungeon of ij, right? You have a 5, you have a 3 at 8 at the neighbor. So you need a 1. No, 4, which is this, okay. Otherwise you will have a negative. What negative? नहीं लेना है क्या ABS? ABS नहीं लेंगे तभी तो नेगेटिव वाला हैंडल हो जाएगा. क्योंकि डंजन आईजे नेगेटिव पॉजिटिव दोनों हो सकता है. और DPI प्लस 1J ये हमेशा पॉजिटिव होगा. ठीक है. And the next case is if J plus 1 is less than n, तो इसको आप कर दो minimum of whatever you have so far and this. Correct? And that will be enough, right?
So can you explain this case?
Yeah. Then just run it once.
Okay.
There is so you have to continue here, but that's okay. But that won't affect this in any case. Still be. that minus the current score. नहीं उल्टा तो नहीं होगा वो. let's take cases लेके आप कर लो इसको. ये if requirement is greater then you just taking the difference, right? If the requirement, तो यही बड़ा हो जाएगा. If the requirement is smaller then you are starting with 1. If it is negative, let's say if this is negative, then irrespective of whether the requirement is bigger or greater, it will be 1 plus this. The only it is some boundary that is missing. Otherwise, let's just try run for the boundary once. For the last cell, it is fine. You will get 1 or 1 minus tangent. Why are we adding 1 again and again? Base case में तो yeah, that's a good point. She is right. This is what the recurrence will be actually. So the reason we don't add a 1 here is because dpij plus 1 already encapsulates that, right? It is basically 1 more than it will ensure always that you will not get a 0 in any, the Prince score will never become 0 at any point towards the, throughout the length of the path, throughout the duration of his travel along that path, right? So that's why we don't need to add a 1 here. How many of you किसी को समझ आएगा ये? Why we don't need to add a 1 here? Yeah, first let's go through the expressions. This expression is fine with everyone. This is just 1 plus. Forget the 1 plus here that we removed. I will explain that. But other than that, is this clear to everyone, these 2 lines? There was one person who wanted me to explain, right? Should I explain any of these 2 lines, line number 20 and line number 23?
Sir, once we are taking max and another, and next time we are taking min. Why is it like that?
That's because we have to take, I'm just everything I have done in these 2 lines. So you need to find so you need to take the minimum out of the 2 possibilities, right? One possibility is from I plus 1 to j. So from I plus 1 to j, if you take that route, what is the minimum health score that you need? That, and what is the minimum health score that you need if you take ij plus 1 route? You need to take the minimum of those 2. So that is what I have done. I have 3 things I have done. I have initialized it with a very large value. What that ensures is that for the boundaries, only one of these 2 if will execute, right? So if this if executes, then we are good because we don't need to take the minimum with the other one. If this if executes, then also this will always be taken into account because I have initialized this to the largest possible value, right? So that's how we take into account the boundaries. And internal cells ke liye both the ifs will execute. So if both the ifs execute, then I am obviously taking a running minimum, right? I am first initializing it with one value and then I am taking the minimum with whatever I have obtained so far and the new one.
So we are taking the minimum of 2 paths.
Taking the minimum.
I plus 1, I to I plus 1 and j to j plus 1.
Yes. So I just try to explain you how this works. So there are three things that I have done here, which takes care of all the corner cases. And this is one common pattern that you will see. I have initialized it to as large value as possible. And in the first, if I don't take the running minimum, in the you can do that also, it's okay. In the second, if I take the running minimum. How many of you understood this, what I'm trying to say here, like why this works? I just try to give you a high level idea of why this works for all possibilities other than the last cell. The boundaries also it works.
So the essence of the DPIJ is that we're calculating the path from I comma j to m-1 n-1, right?
It is what the question is saying. DPIJ is the minimum health score that you need if you start from IJ and travel to m-1 n-1 in such a way that you don't die.
Oh, okay.
It is exactly what the question is saying.
Okay. Understood.
Clear? Is the entire question clear to everyone?
So one syntax related note.
Yeah.
Since we are initializing it with int max, isn't that max is always going to take dp of I plus 1j minus dungeon of ij?
Come again?
I mean the maximum element will be always other than 1 dp of I plus 1 minus dungeon of ij, because we have initialized it with it int max.
So we have initialized it with int max, but we are not using that int max anywhere in the subtraction, because these are values that have been computed. So these will have a this will have a value which will not be int max when we are using it. That's why we are defining it in that order, right? That's all the theory that we have tried to learn. Like what is the order in which you go about solving the subproblems.
Yes, sir, I got it. But why are we initializing int max?
That's because to take care of the case that when only this if executes. So that is for the last column. For the last column, this if will not execute, right? This if will execute. So you want to take this as the value. This should be the value for the last column. So I have just taken the minimum of whatever it has already. So if this does not execute, then it here when this line executes, dpij comes in with int max. If this executes before this, then dpij comes in with the previous value, which is I plus 1 value. So I am able to take the minimum.
Yes, sir.
These are just neat ways of writing the things. You could do a lot of if else's and still get away, which is fine. Like your code will still work. Okay, so
where are you taking the case like next element will be greater or smaller than the present?
All of that is encapsulated in this max.
Then what other condition is doing 23 line?
23 line is for the other I. So we did the entire theory we did for I plus 1j, right? We need to do the same theory for ij plus 1 and then take the minimum out of the two.
Okay.
Because you have two possibilities. We were just discussing on if you are at a given cell and if you go from I plus 1 to j, then what is the minimum health that you need? Then you will also have to do a similar analysis, assuming you are at ij and you take ij plus 1 and then take the minimum out of the two. Is it clear, Jadhav?
Yes.
Yeah, I mean, think more about it. These are not easy to grasp, I understand. ठीक है? हो गया ये सबका? Should I explain why we added a plus 1? Yeah, Karman, sorry.
So again, could we space optimize it further?
Yeah, I mean, all these questions you can.
The mod 2
ये देखो
trick could be applicable here also.
Yeah, see. Let's try that. Mod 2. Just blindly doing a mod 2 everywhere. Any other I? Where in the DP where
Yes,
I have
sir. No.
no right? Dungeon में नहीं लेंगे, dungeon तो
No,
पूरा
no.
चलेगा. यहाँ पर 0 mod 2 लिख देते हैं अंडरस्टैंडिंग के लिए, but it is 0 only. Okay.
Yes.
Clear to everyone? Should I explain why we did a +1? Sorry. Yeah, someone was saying something.
Yeah, sir. Why are you not adding +1?
So that's because, see, that's because when I am at ij, okay, and I am using for I plus 1j, I have already computed the minimum initial health that I need, so that I am able to reach from I plus 1j to m minus 1 n minus 1. I have already computed the minimum health that I need. So whatever that minimum health is, that will always ensure that for this path at any point the prince's health does not go below 0, does not become less equal 0. For all these points along the path, its health will be greater than 0, right? So that is being ensured implicitly from I plus 1 to j. So for ij, so from ij to I plus 1j, now let's take an example. Let's say there was a 5 here, and if you take an 8 here, then you can, then at any point, it will never happen that your score will become 0. It will always be greater than 0. So for this case, you need just 3, right? Why do you need 4? You need 3. With 3, you will get an 8, and then you can come from here to here, and this ensures, the value itself ensures that its score will never fall below 0. Right, Harsha? So
yes, sir, got it.
That's why.
Actually, I thought of asking this question at the start of problem. Why we are adding +1 in the beginning? So I got it now.
Yeah. So now you could do the other cases also. For 5 again, let's say if the value is 5, it is already automatically ensured that it never falls below 0. Then and at the current cell it is 8, you can come in with an 1. You will be good. So those are basically the cases. Negative also is similar to this. So that is the Dungeon Prince question. There are more matrix DPs you could try out. I will give you one more very hard question, which has been asked by Uber sometime. Don't worry too much if you're not able to do it. It's quite hard. That goes by the name. क्या नाम था उस क्वेश्चन का? Cherry. हाँ, cherry pickup. एक second, let's search cherry pickup. 741. हाँ, उबर आएगी भी नहीं अब, तो लाइट ले लो, बट करना है इसको ट्राई। अब नहीं होगा तो दुखी मत होना, फिर कल हम लोग डिस्कस करेंगे, फिर मैं बता दूंगा, आप लोग हाँ कर देना और फिर वी विल मूव ऑन। उबर का सीजी कट ऑफ होता है भाई साहब, 9+ हमारे कॉलेज में नहीं होता है, नहीं
तो
होता।
कहने के वैसे 0 कट ऑफ होता है, पर
हाँ, पर इम्प्लिसिटली वो लोग करते हैं कट ऑफ। अच्छा, सही है। अब क्या ही करोगे उबर जाके, मतलब अब अगले साल जाना उबर, अज्यूमिंग कंपनी बचेगी अगले साल तक। सो ट्राई दिस क्वेश्चन, cherry pickup.
सर एक क्वेश्चन हमने किया था ना जिसमें एक एरे का बताना था कि इसको दो इक्वल सम के सबसेट्स में डिवाइड कर सकते हैं कि नहीं। तो उसको अगर जनरल केस के लिए करना है कि k इक्वल सबसेट्स में डिवाइड कर सकते हैं कि नहीं,
ये हमने
तो
किया था ना।
ऐसा-
आप DSP 1 के और 2 के
Two।
करा था ना ये क्वेश्चन हमने, पार्टीशन इनटू k इक्वल सम सबसेट्स।
हाँ, वो रिकर्जन से किया था ना।
हाँ, बैक ट्रैकिंग रिकर्जन से किया था।
बट डीपी से हो सकता है क्या ये?
DP से हो सकता है क्या? आई थिंक सो। n into k में तो हो ही जाएगा। You could, so the decision there is that when you are at a given, मतलब
Include,
it
exclude
will include. So if you are going ahead with the decision कि वो the current element could be in any of the subsets. So from 1 to k, you have k buckets, and you want to put that current element in any of these k buckets. So if you try that decision, then it is exponential because you get a subsequence. And with include, exclude, but what will be the decision? Like, you include it in the current ith subset or not include it in the ith subset, right? Yeah, I think so. I think आपने ट्राई करा है क्या?
नहीं, मैंने नहीं। ऐसा एक्चुअली क्वेश्चन ये मतलब ये तो मैंने जनरलाइज कर दिया, और एक्चुअली क्वेश्चन था कि तीन मतलब सम बाय 3 सम बाय 3 सम बाय 3 के तीन सबसेट्स करने हैं। तो ये पक्का डीपी से ही है, तो ये डीपी का ही क्वेश्चन था।
हाँ, वो k के लिए भी वैसे ही होगा, वो इंक्लूड इन द फर्स्ट सबसेट, सेकंड सबसेट, थर्ड सबसेट।
बट इसमें प्रॉब्लम है कि जैसे हमने सम बाय 2 का किया था, उसमें तो हमने एक सबसेट ढूंढ लिया, तो हमको पता चल गया कि मतलब दूसरा भी होगा ही, उसका भी सम बाय 2
नहीं,
होगा।
हाँ, इसमें आप वैसे नहीं करोगे, इसमें आप सारे सबसेट्स के लिए रखोगे सम। So you will keep a running sum. You will have a k array, k size का array, जहाँ पर you will keep a running sum of all the elements you have included. So the decision is that for a given element, you and a given, so this will be a 2D DP, n into k. For a given index, that element you can put it in, you can choose to include it in the, हाँ हो जाएगा, उतना टफ नहीं है. So what you could do is you could have a 2D DP, n into n by k, and when you are at a given n, so DP of ij will basically represent, assuming that, so you have two decisions here. You can put this jth element, put this ith element in the jth subset, or don't put it in the jth subset. So if you put it, then you will be left with the remaining elements and the jth subset again, and you can check when the sum exceeds sum by k, then you can move on. But ये exponentially हो जाएगा यार k के लिए. Let me think, I will get back to you. ठीक है, this will be exponential what I am trying to say, but I will get back.
अगर k वाला छोड़ दो एक बार और बस 3 वाला केस ले लो,
3 वाला तो हो
इसमें
जाएगा.
भी, बट उसमें भी कैसे होगा, क्योंकि उसमें 2
3
वाले केस
वाला
में तो हम
में
लोग
इंक्लूड एक्सक्लूड का, हाँ बताओ.
कि 2 वाले केस में तो हम लोग क्या कर रहे थे कि एक सबसेट अगर मिल गया तो क्वेश्चन खत्म, क्योंकि सेकंड वाला भी होगा ही. बट इसमें ऐसा नहीं है ना, इसमें अगर एक हम लोग सम बाय 3 वाला ढूंढ लेते हैं,
2 वाला में आप ये डिसीजन ले सकते हो कि जो करंट एलिमेंट है वो इन तीनों में से किसी भी सबसेट में आप डाल सकते हो. सो यू कुड ट्राई आउट पॉसिबिलिटीज. ठीक है. द रीजन दैट इज नॉट एक्सपोनेंशियल इज बिकॉज दिस इज 3. ऑल सबसीक्वेंसेज ऑफ, मतलब in 3 what you can do, the decision that you can make is the ith element will go into either this subset or this subset or this subset. Looking at the first solution, the first element of the solution of the element of the array will go into either the first subset or the second subset or the third subset. Correct? So you will have some current sum S1, current sum S2, current sum S3 in your DP, and you will have a start index I, and you will have an array. Okay, so this will be your prototype. So the cases is if I goes into S1, you will be left with array I plus 1, S1 plus AI, S2, S3. ठीक है? And if you put it into S2, then you will have S2 plus AI. If you put it into S3, you will have S3 plus AI.
एक बार फिर से बता सकते हो कनेक्शन मेरा?
हाँ, मतलब मैं बोल रहा हूँ कि आपका जो करंट एलिमेंट है, 0th एलिमेंट, you look at the eventual solution. The decision is the eventual solution. जो भी eventual solution होगा उसके 3 subsets हैं, S1, S2, S3, and this 0th element will be a part of one of these 3. It will be definitely a part of one of 3 because you are partitioning, divided, correct? So that is the decision. So you have 3 cases here. It can be a part of 0th subset, the first subset, or the second subset, or the third subset. So if it is a part of the first subset, then you are left with the problem AR now, and this subarray is the problem that remains. So which can be encompassed or represented as array I plus 1. And what are the current running values of S1, S2, S3? It is S1 plus A0, S2 and S3. Okay. So that's what you could do. So this is basically a 4D DP. Right? This is NK cube. अभी जो मैंने बताया ये NK cube है. मतलब there might be better ways of doing it.
Okay.
But I can think more and let you know. So matrix DPs, try this cherry pickup question. This is also a tough question. So that's pretty much it about matrix DPs. Tomorrow what we will do is we will start out with top-down bot approaches. So we will discuss how we can do some of these questions in a top-down fashion instead of doing it in a bottom-up fashion, which is basically we don't want to construct it from the smallest subproblem to the biggest, but instead go from the biggest to the smallest. So we want to take that route. So we will look at questions which some questions, there are some questions which exclusively warrant that you do it in a top-down manner. You will not be successful if you are doing it in a bottom-up approach, taking a bottom-up approach. So we will look at that, and then we will start off with the much awaited. We will start off with, we will do a couple of questions on tree DP, graph DP, not graph DP, tree DP and digit DP, and a couple of questions on DP and bit masking. Did anyone try this burst balloon question? बहुत मस्त क्वेश्चन है वो. This is n square dp, and so we have not done any n square dp with n cube complexity. These are some questions we can discuss them, but they are tough. How Geetans, were you able to do this burst balloons? Cool. What is the decision? Yeah, I can discuss the approach.
The decision was basically the last balloon to be bursted.
Yes. So this is a classical question wherein we look at the last solution, the last element in the solution. That is the decision in this. So that's the hint. Give it one more thought. I can tell you the approach, but give it one more thought. Think about, so the question, by the way, is that you are given balloons B1, B2, B3, and so on till Bn. At any point, you choose one of the balloons, you burst it. This is very similar to, by the way, this is very similar to matrix multiplication, Geetans, right? Matrix chain multiplication. That's a classical question. So if you have done matrix chain multiplication, you will be able to do this B1, B2. So here what we are doing is we have a set of balloons which are arranged in a line. What at any point, what you can do is you can burst a balloon. Once you burst a balloon, the score, you get a score of, what is the score in the question? I forgot the score. Computation. So you get nums left into nums I. Yeah. So you get B2 into B3 plus A into A. B2 into B3 into B4. If you burst B3, you get this score. And now B3 is gone. So now the sequence remains B1, B2, B4, and so on till Bn. So in this way, now you will pick up another balloon, burst it, get a score, add it to the existing score. In this way, you will have an ordering. So you will burst balloons and you will keep getting scores, right? So there will be one ordering of the balloons which will ensure or which will give a maximum score. And you have to find that ordering, or you have to find the maximum score, by the way. So let's think. The first immediate decision that comes to my mind is, why don't you decide the first balloon that you are bursting, right? There is an ordering. So why don't you decide the first balloon that you are bursting? So let's say that we want to, let's say the decision is, the first balloon, the choice of the first balloon that you burst. Let's see. Now let's say, so it could be any BI, right? So let's say you choose BI and you burst it. So this is the first balloon that you have bursted. Now, can you say that your sub problems become 0 to I minus 1 and I plus 1 to n minus 1? Can you say that? If you burst this balloon, can you say that these are the sub problems? So whatever you get from this and B3 into B2 into B4, or Bi into Bi minus 1, Bi plus 1, that will be the answer. Can I say this?
Yes.
No, you cannot. Why can you not say now? Now let's say I'm telling you this, you cannot say this. My question is, I am deciding the first balloon and I say that let's say that the first balloon I burst is ith balloon. So can I say that the total answer is Bi minus 1 into Bi plus 1 plus whatever I get for 0 to I minus 1 plus whatever I get from I plus 1 to n minus 1?
What's the flaw in this?
The flaw in this is that
I think I minus 1 and I plus 1 should be in the same.
I minus 1 and I plus 1 are dependent. I mean, they are linked. So 0 to I minus 1 is not an independent subproblem. That's the flaw in this. Right? So the decision to determine an order for 0 to I minus 1 is also dependent on I, because I is adjacent to I minus 1. After you have, I plus 1, after you have burst I. So that's why you cannot say that from the first balloon that you burst, you can take this call. But now let's say my decision is that I am deciding the last balloon that I burst. Let's say I am thinking about this. So this is the sequence. You will burst balloons, keep bursting balloons. Eventually you will be left with a couple of balloons. Or you will be left with one balloon. So what is that last balloon that you are bursting? If I say that Bi is the last balloon that I am bursting, then this recurrence will hold. Why? Because 0 to I minus 1 will not be influenced by I now, because you are not bursting I. So no matter in what order you burst 0 to I minus 1, the right boundary of I minus 1 is always I. Is always I plus 1. Is always I, right? Because You are not bursting I. Did you get this? You are bursting all these before I. So the right boundary of I minus 1 is fixed. It's always I. Similarly, the left boundary of I plus 1 is fixed. It's always I. So you can compute these two independently. So the recurrence is the same, but the crucial point is to appreciate that the decision is the last balloon that you are bursting, not the first balloon that you are bursting. So the decision is looking at the last element of the solution. So this is one example wherein you look at the last element of the solution. That is the decision. किसको किसको समझ आया ये बात?
लेंथ डीपी से नहीं कर सकते क्या? मतलब
लेंथ ही डीपी है, हम लोग तो अभी डिसीजन का डिस्कशन कर रहे हैं, इम्प्लीमेंटेशन है ना वो तो।
मैं डिस्कनेक्ट हो गया, मेरे को लगा बहुत आगे चले गए।
अरे नहीं नहीं नहीं। How many of you understood this? Is there anyone who understood this? Think about it. We can discuss it again tomorrow. Why is the decision the last balloon and not the first balloon? And the idea is that for the first balloon, you don't have independent sub problems. You always want to find recurrent, take a decision in a manner in which you have independent sub problems that you compute, which are not dependent on the current I. So think about it, and we can discuss again tomorrow this question. So this is a length dp order n cube. So n square is the, for every subarray you will keep, and the decision is you will iterate on the decision. So you have an n cube solution and dp size is n square, 2D dp order n cube. Okay. हाँ ज़्यादा हो गया, चलो हो गया, अब लाइट है. Okay, all right, then we will continue from here tomorrow. Mostly we will start with, we'll look at a couple of top-down approaches, and then we will begin with look at a couple of tree DP questions, a couple of DP with bit masking, some greedy questions also. So it will take another 2 days, I am guessing, tomorrow and day after tomorrow, before we completely, so it takes a week to complete TP. When we discuss, I will tell you what is TP. लीड कोड इंटरव्यू बिट, मतलब इंटरव्यू प्रिपरेशन के लिए कर रहे हो तो यही दो प्लेटफॉर्म्स है. आपको जनरली कॉम्पिटिटिव सीपी के लिए करना है तो आप और प्लेटफॉर्म्स पिक कर सकते हो. हाँ तो फिर उतना काफ़ी है जो आप कर रहे हो, मतलब लीड कोड और आईबी से कर लो. जीएफजी बेकार है, वो आर्काइव है, काम नहीं आता. हाँ नौकरी, फिर नौकरी मिल जाएगी तो फिर भी दुखी रहोगे, दुखी हमेशा ही रहोगे. आर इज आर, सेकेंड आर रोना है, पहला आर आप सोच लो क्या हो सकता है उसका. क्या ये बहुत आर करता है क्या तुषार? ये लगी NIT वारंगल टॉक्स चल रहा है, और किसी को अपने अपने कॉलेज के टॉक्स करने हैं तो अलग अलग आप लोग भी चालू कर दो। हाँ सब करते हैं RR, आप नहीं करते हो क्या? लोग सब फ्रंट बेंचर, ये सब फ्रंट बेंचर्स की कहानी होती है हमेशा, आप देखना तीनों फ्रंट बेंचर्स हैं। बैक बेंचर्स ये सब बात ही नहीं करते, उनको फर्क ही नहीं पड़ता उनको।
सर बैक बेंचर हूँ सर मैं इतनी बार बाहर निकाला गया हूँ ना ICA की क्लास से, मुझे पता है वो घटिया सी क्लास, उसके मुंह पे मतलब मैं इतना बेशरम हो गया, मतलब उसने मेरे को क्लास से बाहर निकाला, मैं उसके सामने कैंटीन पे खड़ा होकर बोंडा खा रहा हूँ।
अरे सही है।
सर सब बैक बेंचर ही हैं यहाँ, ये प्राप्ति को छोड़ के बस। ये मतलब इतनी फ्रंट बेंचर है, टीचर के बिल्कुल बगल में बैठती है, ये सबसे बड़ी RR करती है।
यही है मतलब, फ्रंट बेंचर से बैक बेंचर, लास्ट बेंचर का मोटो सब मोह माया है होता है, और फ्रंट बेंचर मतलब डिक्रीजिंग ऑर्डर ऑफ फक्स गिवन होता है, वो अरेंजमेंट फ्रॉम फर्स्ट बेंच टू द लास्ट बेंच।
रिकॉर्डिंग से कटवा देना ये, वरना गालियां पड़ेंगी मुझे।
कौन देगा आपको गाली?
सर ये है ना सर।
अरे रिकॉर्डिंग से नहीं हटेगा भाई, एडिटर नहीं है हमारे पास। नहीं मैं फ्रंट बेंचर नहीं था, मैं फ्रंट बेंचर था मेरे को जब मेरा 9.8 नहीं था सर पॉइंटर, मैं फर्स्ट ईयर में मैंने डेप्सी मारी थी तो मेरा बहुत ज़्यादा हो गया था, तो फिर मैं कम करने की कोशिश कर रहा था बाकी 4 साल। हाँ तो मैं फर्स्ट ईयर फ्रंट बेंचर था, उसके बाद नहीं था। मेरे को एक महान आत्मा ने बोला था कि डेप्सी मार लेना फर्स्ट ईयर में और उसके बाद चल मारना। तो फर्स्ट ईयर में मैं आगे बैठता था, डिपार्टमेंट चेंज, नहीं डिपार्टमेंट चेंज, सो यू चेंज योर ब्रांच फ्रॉम अनदर ब्रांच टू अनदर ब्रांच, एंड दैट इज़ गिवन ओनली टू लाइक जिसका CG बहुत अच्छा होता है। तो वो मेरे को किसी ने बताया था, तो मैंने वो किया था फर्स्ट ईयर में, बस इतना ही था मेरा, और क्लासेस का नाता वहीं ख़त्म हो गया था जैसे ही मेरा डेप्सी हुआ उसके बाद। उसके बाद मैं एकदम ही वो करता था, मैंने सब ट्राई किया कॉलेज में। मेरे बकेट लिस्ट में था कि मैं एक बार क्लास से निकाला जाना चाहता हूँ, तो मैं एक बार नेटवर्क की क्लास में आई सैट इन द फर्स्ट बेंच deliberately and I took a friend with me and I started talking loudly, निकाल दिया मेरे को, फिर जाके लंच किए मस्त एकदम और जाके सो गए। देन एक था चीटिंग का भी था, अरे बताएंगे कभी कहानी, बहुत सारा कहानी। वी एक्चुअली सॉफ्ट प्लेसेस इन वन ऑफ द सब्जेक्ट्स, बायो BS बायोसाइंस। सो आई एंड वन ऑफ माई फ्रेंड्स, हम लोगों ने सीट चेंज स्वैप किया था क्लास टेस्ट के बीच में। भाई होली पे तो पक हाँ चलो हो गया, अब मेरे ऊपर आ गया तो आई विल एंड द मीटिंग ना। जब तक आपस में RR कर रहे थे तब तक कोई दिक्कत नहीं था मेरे को। क्या आरआर का, हाउ टू नॉट डू आरआर, वो प्रद्युम या भाग्य से करवा लेंगे। अच्छा, कॉलेज के किस्से, हाँ बताऊंगा। सो वी हैड दिस, तो बायो में बेसिकली होता क्या था कि एंड सेम में 2 पेपर होते थे, एक प्लांट लाइफ एक एनिमल लाइफ, और आता हम लोग को घंटा कुछ नहीं था। कल नेक्स्ट डे एंड सेम है, और आज हम लोग सोच रहे हैं करना क्या है, मतलब पास कैसे होंगे। तो एक पूरी कमेटी बिठाई गई और कमेटी डिस्कस कर रही थी कि अब करेंगे क्या, हाउ टू पास। तो लड़के अलग अलग आइडियाज़ बना रहे हैं, कोई बोल रहा है कैलकुलेटर से चीटिंग कर लेंगे, कोई बोल रहा है चीट पेपर ले जाएंगे। तो हमने बोला नहीं। फिर हमने एक प्लान बनाया, उसमें प्लान ये था कि 2 पेपर होते हैं, दोनों सब्जेक्टिव होते हैं, सो प्लांट लाइफ एंड एनिमल लाइफ। एंड व्हाट वी डिड वाज, तो हमने बोला कि वी विल डिवाइड, एक बंदा प्लांट पढ़ेगा, एक बंदा एनिमल पढ़ेगा, और दोनों पेंसिल से अपना अपना पोर्शन लिखेंगे फर्स्ट 1 घंटा, and after that after 1 hour one of the persons will stand up and he will go to the restroom. And then the second person will try to go out, but he will not be allowed to go out. The professor will tell that a person of your slot is already outside, so you cannot go out. So he will come back and he will sit in the other person's place, and then the other person comes back and he sits in the other person's place. So that was the plan, but execution was alag hi tha. Execution was so that was expectations, now reality was different. रियलिटी के लिए आप लोग गैस करना क्या क्या पॉसिबिलिटीज हो सकता है, ठीक है, मेरे को बताना कि व्हाट इज द रियलिटी। फोन्स तो क्लास टेस्ट में हम लोग फाइनल, अभी तो आप लोग का सेम है, हमारा प्लेसमेंट सेम में हम लोग पूछ के चीटिंग करते हैं। हमारे फाइनल सेम में हम लोग क्या किए थे, हम लोग टेस्ट में क्लास टेस्ट में तो किए ही है कि टीएस को सीधा सीधा जाके बोलते सर देखो प्लेसमेंट सेम है, कंपनी आ रही है, ये सब्जेक्ट जो पढ़ रहे हैं अभी हम लोग थ्योरी ऑफ कंप्यूटेशन, काम कुछ आता नहीं है और हम लोग को भी कुछ नहीं आता है। तो वो बोलता तुमको क्या चाहिए, बोले सर फ़ोन से चीटिंग करने दो, बस पीछे बैठेंगे फ़ोन से चीटिंग करेंगे। तो वो 2 बार मान गया था, तो 2 बार ही हम लोग थ्योरी ऑफ कंप्यूटेशन में पीछे बैठ के सब अपने अपने फ़ोन से चीटिंग किए थे, और वो टीए को पता था वो बात। फिर वो जब टीए पेपर वो कर रहा था, डिस्ट्रीब्यूट कर रहा था, तो उसने मेरा नाम बुलाया, तो मैं गया और हंसने लगा। तो वो मेरे मार्क्स देख के हंसता है मेरे 20 में 18 आए थे, तो वो मेरे को बोलता भाई चीटिंग करके भी तू 20 नहीं ला पाया। मैं बोला सर 20 लाना ही नहीं था मेरे को। अरे चलो बाकी चीज आप लोग अपने कॉलेज ऐड में करो। इट्स 12:30। भाग्य तो यूएस का है ना, भाग्य इंडियन ही नहीं है अपेरेंटली, मेरे को पता चला जब मैं मॉक ले रहा था उसका। अच्छा सऊदी रह गया, फिर तो और ज़्यादा मेरे। चलो ऑल राइट गाइस, गुड नाइट, थैंक यू, सी यू अगेन टुमारो।